So what we're going to talk about today is picking the right model. And this is something I think conceptually seems very easy, right? But the more we dig into it, the sort of more difficult the problem tends to be. And let's consider the following scenario. We at Anthropic have just launched a new model. And as usual, there's a lot of noise. Alongside the model launch, we will release a model card. We will give prompting guides. We will give benchmark results. You'll also see a lot of hot takes on X or Twitter from, AGI is here all the way to Anthropic is cooked. And there's, various posts across the internet, again, giving kind of hot takes on the quality of our new model. But the key question often for you guys is, what does that mean for your use case? What does that mean for your business? And should you effectively drop in this new model to your product? Will it be an uplift? Or if you're building greenfield, which model should you select to even start with? And to address that, what we basically want to build is a repeatable process, something you can come back to time and time again that gives you a clear yes-no decision on when to select this new model. In other words, we want to build an eval. So coming back to the original problem, conceptually very simple, right? When you need more intelligence, you reach for Opus. When you need lower latency or lower cost, you reach for Haiku. And when you want some balance of the two, you can use Sonnet. But what about effort levels? Well, this introduces a little bit more depth to the problem. Should we reach for Sonnet with max thinking? Should we reach for Opus with low thinking? Maybe comparing Haiku versus Sonnet with no thinking. And this is just Anthropic. A lot of you will be comparing models, not just the Claude models, but across other providers as well. So how do we frame this? How do we frame this decision? And I think there's really three pillars that most folks tend to think through when choosing which model to use. The first one is the model quality. Effectively, how well does it actually perform on your task? What is the task completion rate? What is the accuracy of the model? And various other metrics you might track. Number two is latency. Especially for customer-facing use cases, latency becomes very, very important. And number three is cost, which is obviously a big consideration for a lot of different customers as well. So I think through the lens of basically these three pillars of quality, cost, and latency, we can start to build an eval around them to help us make an informed decision on which model we should actually use. So the three things we're going to try and take away from today. Number one is it can be a very small, well-designed eval, will be much more important for you guys to assess which model to use than any public benchmark out there. Number two is the model that's right for your use case is not necessarily the one that's cheapest or fastest per token, but the one that is cheapest per successful outcome. And we'll deep dive a little bit more into that later on in the talk. And number three is we have actually quite a lot of knobs and dials that we can twist and turn to kind of move up and down the cost accuracy frontier with a little bit more fine-grained control. Or if you think about that Pareto curve of the performance of the model versus the cost, we can actually shift that curve entirely, and there's a number of strategies we have to do that. But I just want to reflect a little bit on what the public benchmarks at least do and don't tell us. And I think directionally, these benchmarks provide us with some insight as to generally whether a model has improved at coding or various other tasks. So in our model releases, we'll often include benchmark results on things like SweBench Verified or BrowseComp, which are basically what they say on the tin. How good is the model generally at coding? How good is the model generally at research type tasks? However, none of these really tend to match your use case. If you think about a coding agent in production, often it will need to go and research and find some niche specific part about an SDK on the web, and then go and implement that in code. So already we're crossing over two benchmarks. And your workloads often look much more heterogeneous than that. And so, you might have a coding task, but your coding task can still look a lot different than SweBench. Maybe you're using languages that don't even show up in SweBench. So the point being here is these public benchmarks are like somewhat directional and give you a bit of a take on, some of the best models out there. However, for your specific workload, it's incredibly important to build your own evals. So how do we do that? I think you will hear us at Anthropic talk a lot about evals, and we have some other workshops on this. So we're going to do a bit of an express tour. But effectively, what we want to do is build up an eval, which is composed of a set of tasks, and we can consider a task to be the kind of atomic unit of our eval. A task being a kind of test with a set of inputs, some success criteria, and we want to basically build up a data set of these tests. Now, the kind of heuristic I've been using for evals over the course of the last few months is thinking about them much like a maths exam when you're at school. So you have your question, you have your answer that you need to get right, but it's also very important to show the working in between. And I think this is, especially for agentic type tasks, exactly the sort of thing we should think about when evaluating the performance of a model. So we will ultimately compose a data set with a set of questions or inputs to our system. We want to, of course, check that our agent reaches the final outcome correctly, but we also want to make sure it took the right steps to get there. So the point being is the kind of working is as important as the outcome. So I think it's helpful to kind of consider a real life example. If you consider a customer service agent, we might want to build an eval where we use an LLM as a judge to check the final response matches what our expected response should be. But we might also want to use some kind of LLM as a judge to make sure the agent queried your database in the right way to find the customer's details. And I think LLM as a judge can be pretty helpful because let's say your agent is writing SQL, it can be like syntactically a little bit different, and the LLM as a judge can kind of notice that, and as long as the same data is being pulled, it's kind of robust to that. And you can also use deterministic, like code-based evals to make sure, hey, I always want my agent to call this tool to search our internal routines. Or when it's searching the routines, I always want my agent to add an argument to localize the search to whatever country the customer is in. So effectively, you want to build up this set of graders per task where you ultimately will have to do a lot of hard yards of creating these data sets, defining yourself to begin with what is the right solutions and what is the right outcomes and what is the right steps to get there. But ultimately, I think it's one of the highest leverage things you will do. And in a world where we're automating a lot of stuff with AI, taking the time to actually build that eval data set, I think is like one of the best uses of your human time that there is. So the TLDR here is we want to create this reference set of evals that will effectively form the basis of making a much more data-driven decision on picking the right model. Now, we within Anthropic have been building evals for quite a bit of time now, and I think it's worth touching on a few kind of common gotchas that we've seen, a few common errors that we've seen, or failure modes when building evals. So on this slide, there's three main things that I kind of want to call out. Number one is kind of this process of mistaking noise for signal. So the simple thing to do here is once you've defined your eval and you're running it, to make sure you run it a number of times on every task and make sure that the result holds. And if you're seeing a lot of variance in the metrics and results that you're getting, it's maybe a signal to you guys that the task is not super well defined or that your evals are kind of not fully aligned. Number two is infra failures. So you might see your eval results and see the numbers coming out the other side, and something looks a little bit off. Maybe the numbers are really down for Opus. And when you dig into the actual transcripts, you might notice that there's a lot of API failures or a lot of tool call failures. And I want to be very clear, we should separate those from our actual evaluation of the model itself. These are infra issues and not model issues. So I think really like digging into the transcripts and figuring out where a failure happened and figuring out like, did something score low on a benchmark because the model actually didn't perform very well itself? Or was there some kind of infra failure? And again, this is the kind of work that is easy to overlook. It's very easy to like run your evals, get a result the other side, and make a decision based on that. But like actually getting into the transcripts, again, is like a very good use of your time. And then number 3 is this point on silent saturation. So I think the most salient point here is having a data set that is actually representative of the data that you'll see in production, actually representative of the types of questions a human might ask your system. And I think generating this feedback loop, especially once you've launched a product, to collect traces, see what people are asking your system, see the failure modes of where your agent or LLM use case is failing, and put those back into your eval set. So you really get this representative, diverse sample of the sorts of inputs that your system needs to take. And then finally, I think it's worth calling out that every model is a little bit nuanced and has its own kind of quirky behavioral changes. So we will release a prompting guide when we release any new model. And like we do really put a lot of time into that. And I think it's worth reading through, or even just feeding that prompting guide to Claude and asking it to update your prompts accordingly. So I'll give you an example. I was working on a tool within Claude AI, and with Opus 4.5, that tool was like drastically under-triggered. And with Opus 4.6, the tool was drastically over-triggered with the exact same prompt. And so the takeaway here is you will also need to do a little bit of like fine-tuning and adjusting your prompts based on the model that you're using. Claude will ultimately perform a little bit differently between the model variants, and Claude will obviously perform a little bit differently than GPT. So there's some kind of like hand tweaking to be done there as well. And the other big thing I really want you to take away from today's session, I've said it before and I'll say it again, you like really need to read your transcripts of what the agent or model is doing at different points in your system. So I would try and make this as stupidly easy as possible. So setting up good observability, whether it be Langsmith, Brain Trust, or some of the various other platforms out there, making sure if you're building an agent, everything is traced in there from the system prompts, the tool call that the agent made, the tool result the agent gets back. What you basically want to be able to do is dig in and at any point see exactly what the model saw and then how it behaved, because that is ultimately your way to debugging any issues that you have. So I'll give you an example. We ran an eval on Claude Code, and we saw Claude was performing like very, very well on this coding benchmark. When we actually dug into the transcripts, what we found was that Claude was going into the Git history and seeing what it did in previous trials and extracting the answer from there. So if we would have just looked at the headline metrics from the eval, we would have thought like, great, we've made a huge improvement. But it's only by digging into the transcripts that you start to see some of the actually underlying patterns that are emerging, some of the real things that need to be fixed and done. So the closer you can get to the raw data, very much the better. So to kind of recap at this point, we've talked a little bit about how building a private eval is extremely important for making a data-informed decision on picking the right model. We've talked a little bit or done an express loop of actually building an eval and some of the common failure modes in doing so. Now what I want to talk a little bit more about is what are the tools and dials available to us to kind of move up and down that frontier and trade off between cost and quality, or latency and quality. And let's start off with a little story. So we had a code fix pipeline internally, and it was a pretty simple task. So the team used Haiku 4.5 with no thinking to begin with and scored 92%, as you can see on the screen there. The team ultimately wanted to get 100%, so they turned thinking on and actually got there. Again, this was actually a pretty simple pipeline. And they actually decided to rerun the eval with Sonnet and Opus as well. And as you can see on the screen, they actually both scored 100% as well, but counterintuitively took way less time in doing so. We weren't super cost constrained on this task. We just wanted it to run as quickly as possible. Now, this is very interesting, right? Because on the face of it, you would think that Haiku would be much faster, but actually some of the more intelligent models can be much more efficient from a time perspective because they can do things in fewer turns. They can effectively plan a little bit more strategically. They don't need to spend as much time researching to validate what they're going to do is correct. And so what I think we can do is start playing around with these configs, thinking and effort to really extract the maximum value for our specific use case. I think it's worth just touching slightly upon what both of these things are, because we've played around with them quite a lot. There's different types of thinking, different types of effort. So let's just recap slightly. From Sonnet 4.6 or our 4.6 class of models onwards, we have adaptive thinking. So the model itself will decide how much it needs to think for a given task. And this is effectively Claude's scratchpad to think before it asks, think before it works, in fact. So this is system 2 type thinking. And then we have effort. And this will tell Claude how much to write across both thinking, tool calls, and responses. So you can have low thinking with high effort, for example, or you can have no thinking but still use effort parameters. Effort is basically telling Claude how much effort or work it should put into this task. Thinking is giving Claude a scratch pad to think before it acts. And we can effectively use both of these configs and dials to have quite a lot of fine-grained control of where we want to be on this accuracy cost curve. So another example here is, again, another counterintuitive point. When we released Opus 4.5, what we saw is Opus 4.5 on screen is the orange line there, is that it was, again, able to complete tasks and have a high or higher level of accuracy than Sonnet and significantly fewer number of output tokens. And again, if you were just going off the vibes of smaller model, runs faster, you probably would have chosen Sonnet, not knowing that Opus can actually complete things faster and with a lower number of tokens. I think the other thing to call out on this slide is you can see this Opus spread between the different levels of effort. And what you can see there is you can then make some nice trade-offs between, am I optimizing for a lower number of output tokens or am I optimizing for accuracy? And if you want higher accuracy, you can choose higher levels of effort. Or if you want lower latency, you can probably choose lower levels of effort. So you can use this effort parameter to really have much more control over just selecting a model alone. The other thing that at least makes me very excited is actually shifting that frontier entirely. And I think there's a couple of hacks here that we can use in order to not just move along that curve, but shift the curve entirely. And the first one is prompt caching. So with prompt caching, we have a bunch of guides online, and I would really encourage you to read into it more. But effectively, when you're using prompt caching and you're basically using a prefix of a prompt that's saved, pre-computed and pre-cached, you pay 1/10 the price of the list price of input tokens. So effectively what this means is you can get Opus quality at Sonnet cost, or you can get Sonnet quality at Haiku cost. This is one of the most effective strategies we use in a lot of our products. We use it extensively in Claude Code, we use it extensively in Cowork. And to kind of benchmark for yourselves a little bit, a lot of the best AI systems and applications we see have prompt cache hit rates of around 80 or 90%. So that's kind of your goal to aim for. But this unlocks whole new use cases, right? If we can use prompt caching effectively, we're paying 1/10 of the list price of input tokens, then suddenly we couldn't afford Opus and now we can. Or maybe there's whole new use cases and budgets that are opened up because we were able to save so much money. And the other thing to call out here is in our APIs and in our SDKs, we return you the token metrics, not only the raw tokens consumed, but the prompt cache tokens on the input. So we make it very, very easy for you guys to measure your prompt cache hit rates as well. So I'd really encourage you to effectively measure it, hill climb it, and try and get your prompt cache hit rate as high as possible. The other kind of main thing I would mention when it comes to prompt caching The simple thing that works, especially if you're building an agent, is use this strategy of append only. So if you have a system prompt, don't have too many dynamic variables in there. The common failure mode I see here is somebody putting a date time variable in their system prompt. So with every turn, the time ticks up and you break the cache. Effectively, I would treat everything in your messages array that you're sending to the API as immutable. Once it's done and you're going and adding only, I would append only to your messages array. And this is like the easiest surefire way to make sure you don't break the cache. Tarek from our Claude Code team, one of the main engineers on the Claude Code team, has written and talked about this extensively. So I would like go and look at some of the stuff he's written about how he implemented this in Claude Code as well. And the second thing I want to talk about is context hygiene and context engineering. My kind of hot take here is people spend too much time thinking about these like super complex multi-agent orchestration systems and not enough time doing the simple thing that works, which is just like good context hygiene and good context engineering. So effectively, if we can improve the token efficiency of our tool responses, we can save a lot of tokens that we're putting into the model, saving cost and improving latency. And we also have this kind of secondary effect of, because we've provided Claude with cleaner, more efficient data, Claude's responses tend to be better and more accurate as well. So if we look at the example of the screen, let's pretend we have a tool which returns sports data, in this case, Premier League scores. And there's a few changes we made here. Firstly, we use Markdown instead of JSON. Secondly, instead of these full inefficient date timestamps, we just put a very simple date timestamp. And then we also added a day of the week, so Claude much more easily understands rather than having to think too much about what day of the week every game is happening. And in just cleaning up this response, we see a 66.4% reduction in tokens from this tool response. And that compounds every time, right? If you're having an agent that is running multiple turns, your tool response doesn't just show up once, but on every single turn in the conversation. So these small hygiene things really make a huge impact, and I can't emphasize this enough. A couple more examples of this that I've worked on. I was working on a web search use case with a customer, and we effectively deduplicated articles that were returned from the same search, or from different searches, in fact. And this one trick, effectively, of multiple searches running, taking the articles and deduplicating them before they're returned to Claude, led to a 77% reduction in the number of input tokens that Claude was receiving, a 65% reduction in cost, and Claude's accuracy actually went up 9%, because again, it's having to reason over less data. And these metrics sound kind of like plucked out of thin air, but these are run, and we can actually measure them because we built evals to begin with. And this is like huge amounts, right? If you can save 65% cost just by doing good context engineering, you can think again, this opens up the ability to use a more intelligent model, or this opens up the ability to go and run whole new use cases for the given budget that you have. So again, I would encourage you not to just take an API response and pipe it back through your tool, but to actually have your tool, especially a lot of tools wrap APIs, and be a little bit more thoughtful. Clean up that JSON response you get back from the API before passing it back to Claude. Much like a human, make it as simple and easy to read as possible. In doing so, you'll reduce the number of tokens provided to Claude, and you'll have this, again, secondary effect of improving accuracy across a lot of use cases that you have. So 3 main things to take away before we get into the workshop. Number 1, a small, well-designed eval is going to teach you so much more about which model you should use than any public benchmark out there ever could. So spend time investing in building that eval. Number 2, the right model is not the model that is cheapest per token. The right model is the one that is cheapest per successful outcome. And once you've built that eval, you can effectively run Claude with multiple different models, multiple different configurations, see that Pareto frontier, And then you have the choice of where you want to select along it. And then number 3, use these different dials that we have, effort, thinking, prompt caching, and context engineering, to have much more fine-grained control on where you want to end up on that frontier, or shifting the frontier entirely. And I think if you can do those 3 things, you'll end up in a pretty good place when it comes to choosing the right model for your use case, even unlocking new use cases, being able to access higher intelligence at a lower cost. So now I want to move into a workshop that you can follow along with yourself. And you can go to this link here. So it's cwc26.short.gy/workshops. And I'll just give you a minute to get there. Cool. I think we're slightly strapped for time, but we're going to run 5 minutes over. I think it's all good. Cool. Hopefully you're now all at that link, and we can switch over to the screen. So effectively, what we're going to do in this workshop, and you can go and do this in your own time as well, is we've built a skill that we've provided up there in the top left that you can see, which will audit your existing evals, but can also do a sweep of the eval that you've set up, and basically instrument it so that it runs across multiple models, multiple thinking level, like thinking off and on, and multiple effort levels. It will then take those results, plot them, save them, and format them nicely so you can basically see your eval performance across different models, across different thinking levels, and across different effort levels. So in this case, we're doing it with TauBench, which is basically a benchmark of customer service agent use cases. And in this case, we're focusing on the airline side of TauBench. In the README for the workshop, you will see instructions on, firstly, how to download and set up TauBench yourself. And again, you can give this prompt here to Claude. Claude will go and set it up for you. Then the next part, I've already downloaded TauBench for the sake of time. The next part is to basically run the skill, instrument the code so that we run the eval across different models, different thinking, and different effort levels, and then run the eval itself. So let's ask Claude to do this. Can you see okay, or should I zoom in? Yeah, we can see okay, thank you. Okay, so we can see Claude has successfully loaded the skill. And in the meantime, I'm going to kind of skip directly to the results in the interest of time in the Blue Peter, here's one I ran earlier way. So this was effectively the results from running this sweep. And you can see we've been very easily able to run the benchmark across all 3 models, Haiku, Opus 4.7, Sonnet 4.6, with thinking off and on and across different effort levels. And the results, to me at least, were pretty surprising. So if we take a look at this first chart, we see the pass rate per task plotted against average output tokens per task. And what we can see is, maybe as we would expect, Opus 4.7, with thinking on, with high effort, has the highest pass rate. But it actually is able to do so with a lower number of tokens than Sonnet consumed for the same use case. If we go to the next chart, it's pretty interesting as well. So we can see, even though Opus was the best performing on high effort, it's also clearly the most expensive. So if we're optimizing in this case for just pure pass rate, then we would pick Opus with high thinking, right? Whereas if we have to optimize for cost, well, then it becomes a little bit different, because we see that Haiku with thinking on actually was able to perform similarly to Sonnet with thinking on and a high level of effort. And then if we go down to the final chart, we will see something somewhat similar, but again, very interesting. So Opus with high effort and thinking on was actually able to perform faster with lower latency than Sonnet was with a similar level of thinking. But what these charts, I think, more interestingly tell us is it gives us the data to make an informed decision on which model and config to choose. We can now identify some of these more non-intuitive properties of the models at different thinking levels, and we can make a decision trading off our criteria of what is important, whether that be latency, whether that be cost, or whether that be model quality. So I think we are definitely over time. So I'm going to end there for now. But just to leave you again with the core takeaways. If you want to pick the right model, you really should build an eval for your use case. For those of you folks who work with us in Anthropic and the Applied AI team, like we're very much here to help you build those. Number two is really try and optimize for the things you care about in your use case. So once you've built your eval and you're making these data-driven decisions, you can then pick, am I optimizing for intelligence? Am I optimizing for latency? Am I optimizing for cost? And then number three is you can shift that curve entirely by actually doing good context engineering, by using these strategies like prompt caching to get more out of the model itself. Thank you very much.
I work at DeepMind, everything related to agents on Gemini or Gemini API. So if you have some questions afterwards, some concerns, some bugs, some issue, please let me know. We're going to talk today 10 minutes about why engineers struggle to build agents. And I see this every day internally at Google, but also externally at Google. And I brought 5 examples on like what's really different to how we built traditional software a few years ago and to now how we build agents. And if we like on a high level compare them, right, when we wrote software, we created a spec, a PRD, wrote code, sometimes created tests to make sure our code works. We deployed it and then our user used it. And when building agents, things are a little bit different. We define instructions on what we want our agent to do. We run it, we observe what it does, we maybe adjust our prompts, maybe we adjust our tools, we run it again, and we have like this iterative loop of how can we improve and make our agent way more reliable, which is very different to how we build software. And like something I like to compare it to is like traditional software is more like we acted as a traffic controller, right? We had control over the street lights, over how fast you can go, which road you can use, basically how the car drives. And now with agents, we are more of a dispatcher. We tell the agent, hey, I want to go to London, and I'm from like Germany. I could use the train, I could fly, I could use my car and go like under the water. And it's more about, okay, we define the goal on what we want the agent to do, but we don't define the exact step the agent needs to take to achieve that goal. And I mean, every one of you has probably seen in their coding agent that sometimes it does something very weird, but at the end it achieves the outcome. And that's what we want to do. So starting with the first example, text is our new state. I mean, traditionally we had data structures and everything was kind of mapped to Boolean or to like flags we could check. So initially when we created, for example, a deep research agent returns a plan to you, okay, I'm going to research this and that. In traditional software, we might have had an accept plan or deny plan, but we couldn't catch semantic meaning. And now what we have with LLMs is they can understand the semantic meaning. So for example, if I have a deep research request on like doing some market research, I can approve the initial plan, but I can also at the same time provide additional information. So maybe I want to focus on like the US market and ignore California. Maybe I want to provide something additional and not have like this multiple steps, right? Traditionally, I would probably set decline, and then it has a follow-up. I might need it to provide more input, create a new plan, and continue. And another good example is everything related to memory and personalization we do cannot really be mapped to data structures, right? The example I have is like, I'm from Europe, so I mostly use Celsius. But what if I would like to use Fahrenheit for cooking, right? Previously, we might have some flags on like the user profile is Celsius or is Europe or use Fahrenheit, but I couldn't like dynamically adjust based on the user preference, based on what they provide. So really it's all about text and context. I mean, it could be images, video, or audio as well, but we no longer are really operating in those clear structured data concepts. The other thing is we should start handing over control. And the trap or the example which we might have from like previous customer support is like when a user reached out, hey, I want to cancel my subscription. I might have had a classification model which kind of classified the intent. Okay, the user wants to churn, and then I had a predefined workflow of, okay, do you try to sell it? Do you cancel the subscription? But there was no like dynamic kind of option to react to it dynamically. And maybe instead of like going through the subscription cancel flow, what if your agent like kind of tries to understand the meaning and like offers something in except to like the subscription, and the user changes their mind, and now you have like a whole different intent. And it's very hard to model all of those differences and uniqueness and to do like all of those stateful workflows we had before. So we need to like trust into the LLM or like hand over control that we are no longer working in those purely deterministic environments. The third one is errors are just inputs. So if something in your agent flow fails, we need to treat it as a normal input, as very similar to a user input. In Go, we already do this, right? Function call can be an error or can be a value, and we treat them kind of equally. And we have to do this for agents very similarly. In the past, HTTP requests were very cheap. When some search, some product search failed, you just rerun your request, you redid all of the work, which was okay. But now if you have like an agent which takes 5 minutes, 15 minutes, and something in the flow breaks, and you would start all over, you would need to spend a lot of compute again to like do all of the previous steps. And you also might lose the existing context. So we cannot like just start over the whole process. We need to kind of understand and treat errors differently, provide them back to the model, maybe have some other workarounds, some additional checks that we basically keep going forward in the flow and not like starting over from the beginning. The fourth example or step is like we need to move from unit tests to evals. So when building software before, right, we wrote integration tests, unit tests, smoke tests, and all kind of different tests. And we assume that when we provide input A for our code B, we will always get C as an output. And that's not longer the case with agents. Agents are non-deterministic. We cannot always guarantee that the same input will lead to the same steps and the same result. So we need to move from unit tests to eval. We need to test how often something works, because agents are only successful if they are really reliable, right? If you have a customer agent and the same prompt only works 1 out of 10 times, it's nothing really you want to put in production, and it becomes very flaky. So we need to test on evals, on how many times it passes, and compared to traditional software, results are very subjective, right? An outcome can be very different if you ask it to create a research report, if you ask it to create a customer feedback kind of scenario, and we need more like qualifying feedback. LLM as a judge or human expert, for example, is a good way. And we always need to trace what the agent is doing, but we need to create on the output. Maybe the agent decides for like one user, it needs to do like 4 more steps to do more research. Then for the other user, it consumes maybe a few more tokens, but at the end, the outcome is really what we need to measure and want to measure in terms of success. And then the last part is agents evolve and APIs don't. And if you have worked on the backend and if you have built an API, you might have seen a lot of methods, API endpoints, which feel very self-explaining to you, like delete item feels very self-explaining if you're working on like the product API. But an agent doesn't see the code, an agent doesn't have the context and the background from all those years from you working on the API. So we need to build APIs or tools which are really agent-ready, which are self-documenting with semantic interfaces. I would assume if you have like a product microservice and you have a delete item endpoint with an ID, you don't need to like define a docstring what the ID is or what happens if something fails. But our agents only see like the function schemas and the docstrings and the tool definitions. So on the first look, they don't really see what the delete item method does. That's why we need to really adjust to, hey, We need methods, tools which are written for agents to be used and not assume long year developer expertise in people who have built the API. So to summarize everything, we need to give trust, but we also verify. We should stop fighting the model. You should not try to force the model into this one specific workflow with step one, do this, step two, do the other thing. We need to preserve meaning. Everything is a context now. We no longer have those very well-defined data structures for all of our applications. We need to design for recovery. Models are not perfect, agents are not perfect, especially if we have longer running agents. There will be some very weird things happening, so you need to design for recovery. We need to evaluate and then don't only assert agents are not 100% reliable. We need to find the right balance between how many times our run need to be successful to provide it to the user. And last but not least, build to delete. The bitter lesson is what every one of us is learning is software is disposable. We are going to rebuild many, many times the same things with better models, better agents. Things will change. And yes, it's also available on my blog. So if you want to look a bit deeper with some code examples, and if not, if you have any questions, feel free to reach out to me. And perfect on time. Thanks.
New college graduate today, and I have a choice between two. One that is no clue what AI is, and one that is expert in using AI. I would hire the one who's expert in using AI. If I had an accountant, a marketing person, the one that is expert in using AI, supply chain, customer service, a salesperson, business development, a lawyer, I would hire the one who is expert in using AI. And so I would advise that every college student, every teacher should encourage their student to go use AI. Every college student should graduate and be an expert in AI. And everybody, if you're a carpenter, if you're electrician, go use AI. Go see what it can do to transform your current job, elevate yourself. If I were a farmer, I would absolutely use AI. If I were a pharmacist, I would use AI. I want to see what it could do to elevate my job, so that I could be the innovator to revolutionize this industry myself. Mm-hmm. And so that would be the first thing that I would do, and then I would also help them. It is the case that the technology will dislocate and will eliminate many tasks. And because it will automate it. If your job is the task, then you're very highly going to be disrupted. If your job's purpose includes certain tasks, mm-hmm. then it's vital that you go learn how to use AI to automate those tasks. And then there's the world of spectrum in between.
And by the way, the beautiful thing about AI, so the chatbot versions, is you can break down, you have anxiety, and you can break down the problem by talking to it. I've recently, it's really just incredible how much you can think through your life's problems and I don't mean therapy problems. I mean very practically, okay, I'm worried about my job. What are the skills? What are the steps I need to take? How do I get better at AI? Everything you just said, you can literally ask and it's going to give you a point-by-point plan. I mean, it's just a great life coach. Period.
I don't know how to use AI, and the AI goes, well, let me show you.
Exactly.
In this video, you're going to learn what AI agents are, not just in theory, but in practice. We'll look at the ideas behind modern agents, and then we'll build your very first AI agent step by step using Google's ADK. By the end, you'll understand how agents reason, act, and adapt. And you'll have code that you can actually run yourself. So what are AI agents? At the simplest level, an agent is software that doesn't just answer, it can decide and take action. Instead of generating a single response like a traditional chatbot, it looks at your request, figures out what steps need to be taken, maybe calls an API, runs code, looks at the results, and then decides what to do next. One of the clearest explanations comes from the research paper React, synergizing reasoning and acting in language models. The idea in that paper was simple but powerful. Language models shouldn't just generate text in one go. They can actually reason step by step, take an action like calling a tool or API, observe the results, and then decide what to do next. That cycle of reasoning, acting, observing, and adjusting is the foundation of how modern AI agents work. And it lines up with how it's defined. Systems with reasoning, planning, and memory, with enough autonomy to adapt and make decisions on behalf of the user. Now, not all agents behave the same way. A useful way to think about them is in three broad patterns. First, we have sequential agents. These run step by step like an assembly line. Step 1, then step 2, then step 3. They're predictable but rigid. Second, we have reactive agents. These decide in the moment. They look at the current state and ask, what should I do next? Maybe tool A one time, tool B the next. They're flexible, but they don't plan ahead. Lastly, we have deliberate or planning agents. These pause to sketch a plan, then execute. Think about booking travel. You don't just buy a flight randomly, you pick dates, hotels, and then that's the order of steps that you follow through. So which of these is the right one for you? It depends on the problem. For simple, predictable flows, sequential is fine. For dynamic, reactive works better. And for multi-step goals with dependencies, you want planning agents. Okay, that's the high-level view. Now let's actually build an agent so you can see these ideas in action. We'll build a blog writing agent. You give it a topic, it will generate a structured outline, turn that outline into a full blog post, and then suggest the alternative titles and hooks. This is where ADK's categories comes in. As we walk through the code, notice how the planner and writer agent are LLM agents, which are powered by a model. They're wrapped in loop agents, which are workflow agents in ADK. These handle retries automatically if validation fails. And if we ever wanted something beyond that, ADK would also let us extend a custom agent by subclassing the base agent. So let's set up the environment and then go line by line through the code. First off, you need to install UV. You can do that by running the command right here. Secondly, you need to install Google ADK because we need to obviously use ADK in this. And then let's create a file called agent.py in your IDE. We need to import these key libraries, and then we can start building out our very first agent. So the first agent that we're building out is called the blog planner. Its only job is to take a topic and turn it into a structured outline. We give it the name blog planner so it's easy to identify, and we tell it which model to use, which comes from our environment file. The description is just a human readable note. The important part of the introduction is here we actually tell it what to produce, which is a markdown outline with a title, a short introduction, 4 to 6 sections with bullet points, and a conclusion. By spelling that out, we make the output much more reliable. Finally, look at the output key. We set it to blog outline. This means whatever this agent writes will be stored in shared state under that name so that the next agent that can pick it up can do it automatically. Next, we add a second agent, the outline validation checker. This one doesn't write anything new, it just checks the outline. Its instruction is strict. If the outline in state has a title, an intro, 4 to 6 sections, and a conclusion, it must answer with the word OK. If something is missing, it must answer with the word retry and explain what's wrong. That way, we can automatically decide whether to accept the outline or try again. To connect the planner and the checker, we wrap them inside a loop agent called Robust Blog Planner. The loop first runs the planner, then the checker. If the checker says OK, we're done. If the checker says retry, the loop runs the planner again with the same instructions. You can do this up to 3 times. This gives us a safety net, so if the model forgets something, it has another chance to get it right. Now we create another agent called Blog Writer. This one takes the outline we just saved in blog_outline and turns it into a full markdown blog post. The instruction tells it how to write. It should assume the audience is software engineers, skip the basics, and focus on practical insights, explain both the how and the why, and include short code snippets where helpful. It should also follow the structure of the outline with proper headings. The finished draft is saved under blog_post in shared state, ready for the next step. Next up, we're going to add another checker, this time for the post. It's called Blog Post Validation Checker. It looks at blog_post and checks if the article has an introduction, sections that match the outline, a conclusion, and clear explanations. If it passes, the checker says okay. If not, it says retry and lists the fixes which are needed. Just like with planning, we combine the writer and its checker into a loop agent called robust blog writer. This makes the system automatically retry the writing step until the validation passes, up to 3 times. Now, we wrap each loop, the robust blog planner, and the robust blog writer as tools. This is what lets the root agent call them directly without worrying about what's happening inside. Finally, we put it all together with the root agent called Blogger. The instructions for Blogger are simple. When a user gives it a topic, first it calls the planner tool to make an outline, then it calls the writer tool to draft the full post, and finally it adds 3 alternative titles and 2 tweetlet hooks. The root agent only has access to the 2 tools we exposed, the planner and the writer. So its workflow is clear and controlled. You give it a topic, it plans, it writes, it checks, and then it gives you a polished blog post. You've now successfully written your first agent script. The next step is to actually run it. Head into your terminal and launch it using this command with ADK Web, so you can view everything inside a simple UI. Once that's running, open the local ADK web link in your browser and start interacting with the agent directly. To kick things off, I'm going to ask it to generate a blog on the top 10 use cases for AI agents. Let's see how it plans, writes, and delivers results. Your sub-agents will then work together to create a blog post. And that's it. You've built and run your first AI agent with Google's ADK. We started from the idea of what agents are, then walked through the code step by step, and finally saw it come to life in terminal. Thank you for watching. Check out the description box for all the resources and code mentioned in this video. Check out this next video to learn how to connect your AI agent to an MC.
So, Dario, we're at Davos. There's a lot going on. But I wanted to start with a big picture question, which I'll characterize like this. It feels to me that this time last year, everybody was very excited about AI, and everyone was talking about what AI can do, its potential, its capabilities. It feels to me as though the debate has shifted somewhat this year to be less what can AI do to what is AI doing to the world. And I know that you think a lot about these things. So my question is, do you think businesses, policymakers, governments, whatever, are doing enough to prepare for the impact?
No. I'll explain the longer version now. I've been watching this field for 15 years, and I've been in this field for 10 years. And one of the things I've most noticed is that there's been a surprise. The actual trajectory of the field has been surprisingly on the same trajectory, whereas the kind of public opinion and the reaction of the public has oscillated wildly. I would say that in 2 different ways. One is the capabilities of the technology. Every 3 to 6 months, we have this reversal of polarity, where the media is incredibly excited about what the technology can do. It's going to change everything, and then it's all a bubble. It's all going to fall apart. And what I see is this smooth exponential line where, similar to Moore's law for compute, we basically have a Moore's law for intelligence, where the model is getting more and more cognitively capable every few months, and that march has just been constant. The up and down. We invented a new thing. It's all going to crash. It's hitting a wall. It's going to go crazy. That is a public perception phenomenon. That's on the capability of the technology. I think there's a similar thing on the polarity of whether the technology is good or bad. Mm-hmm. In 2023 and 2024, there was a lot of concern about AI, right? There was, concern AIs are gonna take over. There was a lot of talk about AI risk, AI misuse. Then in 2025, the political wind shifted, as you say, to AI opportunity. And now they're sort of shifting back. And I think throughout all of this, the approach that I have tried to take and the approach that Anthropic has tried to take is one of constancy, of saying that there is balance here. And balance of a very strange form, because I think the technology is very extreme in what it's capable of doing. But I think its positive impacts and its negative impacts, that, they both exist, right? I wrote this essay, Machines of Loving Grace, about a year and a half ago. It had a very radical view of the upside of AI, that it would help us to cure cancer, eradicate tropical diseases, kind of bring economic development to parts of the world that haven't seen it. And my view hasn't changed. I believe all of those things. But the other side of it, which I'm now kind of writing more about, and may release something about soon, is bad things will happen as well. If we just for an example, as one of the risks, we take the economic side of it. My view is the signature of this technology is it's going to take us to a world where we have very high GDP growth and potentially also very high unemployment and inequality. Now, that's not a combination we've almost ever seen before, right? You think of it as high GDP growth, that's lots of stuff to do, lots of jobs for everyone. It's always been like that in the past. We've never had a technology that's this disruptive. So the idea that we could have 5 or 10% GDP growth, but also 10% unemployment, it's not logically inconsistent at all. It's just never happened that way before. And I'm really quite for those both reasons, excited and worried. If I take an example, something like AI coding, the latest model release, Claude Opus 4.5. I have some engineers, some engineering leads within Anthropic who have basically said to me, I don't write any code anymore. I just let Opus do the work and I edit it. We just released a new thing called Claude Cowork. We can go into that later. But this was a version of our tool, Claude Code, for non-coding. This was built in a week and a half, almost entirely with Claude Opus. There are still things for the software engineers to do, right? It's like, even if the software engineers are only doing 10% of it, they can, they still have a job to do, or they can take a level up. That's not going to last forever. The models are going to do more and more. And so there's an incredible, this is a microcosm. You can see there's an incredible amount of productivity here. Software is going to become cheap, maybe essentially free. The premise that you need to amortize a piece of software you build across millions of users, that may start to be false. Like, for this meeting, it might cost a few cents to just say, I don't know, let's make some apps so people can talk to each other. Or, it just may be very flexible and recyclable. But at the same time, there are whole jobs, whole careers that we built for decades that may not be present. And I think we can deal with it. I think we can adjust to it. But I don't think there's an awareness at all of what is coming here and the magnitude of it.
So it's so interesting when you say that. So how do you think, in a world of high GDP growth, but also high unemployment, what does that do to society? And you say there are, people aren't thinking about it now. Can you give concrete examples of how society might organize itself to adapt to such a world?
Yeah. So, I think there's a few things. The first thing that we've done, that we've focused on, and this is not a solution so much as it is a first step, is we have this thing called the Anthropic Economic Index. We've had it for about a year. We've updated it, I think, 4 or 5 times now. And what that does is it's a real-time index that lets you track what our model Claude is being used for. It goes across all the conversations and kind of uses Claude in a privacy-preserving way to kind of statistically query how Claude is being used. What are the tasks it's being used for? To what extent is it automating versus augmenting tasks? What industries is it being used in? How is it diffusing across states in the United States and countries in the world? We've just added kind of more and more detail here. And my view is, until we can measure the shape of this economic transition, any policy is going to be blind and misinformed, right? Many policies have gone wrong because they're based on premises that are fundamentally incorrect. So that's step one. Step two is I think we need to think very carefully about how do we allow people to adapt, right? People can adapt more quickly or they can adapt more slowly. This can mean adapting to use the technology within existing jobs. This can mean adapting, from one job to another job. For example, I think there are probably going to be more jobs in the physical world and less jobs in the knowledge work economy. Now, maybe eventually robotics, makes progress, but I think that's on a slower trajectory. So that's one. Are there jobs that have still kind of, really value a human touch? Some of them do, some of them don't. We may find out how important that is in the market and where it's most important. At the level of companies, what are the moats when software becomes cheap and then subsequently the rest of knowledge work becomes cheap? We don't know. We've never quite asked that question. We've thought about moats in a certain way. So there's going to be a huge scramble at the level of companies. So teaching people to adapt, teaching them what to expect, I think is the second step. And the third step is I think there's going to need to be some role for government in a displacement that's this macroeconomically large. I just don't see how it doesn't happen. The pie is going to grow much larger, right? Like the money is going to be there. Like, the budget may balance without us doing anything because there's so much growth. The issue is distributing it to the right people. And so I think this is probably a time to worry less about disincentivizing growth and worry more about making sure that everyone gets a part of that growth, which I know is the opposite of the prevailing sentiment now. But I think technological reality is about to change in a way that forces our ideas to change.
So obviously, in your desire to create this greater sense of urgency, are you speaking to people in the administration? I mean, Anthropic hasn't always been the sort of first on the guest list for this administration, but do you have people there that you're talking to?
I have said it to them myself, and to be clear, there are plenty of things we agree on, right? I think the AI action plan that the administration put out in the middle of this year actually had some very good ideas here. I think we probably agreed with the vast majority of it. But I think most of all, we just want to say these things in public and kind of have a public debate about them, right? We don't control policy. I think the most useful thing we can do is describe to the world what we're seeing and provide data to the world. And then it's left to the public in a democracy to take that data and to use it to drive policy. We can't drive policy on our own.
Are you going to be talking to officials while you're here? Have you been along to USA House yet?
I've not been to USA House. I will be talking to officials during my trip to Davos.
Good. So just to go back to Anthropic then. So you founded Anthropic specifically because you were worried about that you didn't think that OpenAI was taking safety seriously enough. Now, some people say that, the competitive pressures mean that you've gone more hawkish now. I mean, are those competitive pressures, to keep up with China, and keep ahead of China, all the rest of it, do you think they have compromised your safety principles?
So we've taken a very different route than some of the other players have. I think one of the good choices we made early was to be a company that is focused on enterprise rather than consumer. And I think, it's very hard to fight your own business incentives. It's easier to choose a business model where there's less need to fight your own business incentives. So, I have a lot of worries about consumer AI that it kind of leads to needing to maximize engagement. It leads to slop. We've seen a lot of stuff around ads from some of the other players. Anthropic is not a player that works like that or needs to work like that. We just sell things to businesses and those things directly have value, right? We don't need to monetize 1 billion free users. We don't need to maximize engagement for 1 billion free users because we're in some, death race with some other large player. And so I think that has let us think more carefully. But even with that, we have made sacrifices. We do all these tests on our models that others have not done. Some other players have done them, but I think we've been the most aggressive in when we run tests that show up concerning behaviors in our model, these things around deception, blackmail, sycophancy that we show in tests and that are present in all of the models. But we make sure to always talk to the public about these things. And we've pioneered the science of mechanistic interpretability for looking inside models. So have we been perfect? Of course not. I think we've done a generally good job. I mean, you mentioned China. I think that's not about competition. That is about actually the public benefit mission. Is I'm worried that if autocracies lead in this technology, it will be a bad outcome for every single person in this room.
What are your specific concerns there? Is it about the chips, about sharing data around chips, or?
Yeah, well, I mean, the kind of means is selling the chips, right? That's the thing that I think will have the most impact on who is ahead and who's not. But the concern, and it's not about any particular country, or certainly not the people in any country. It's about a form of government. I am concerned that AI may be uniquely well suited to autocracy and to deepening the repression that we see in autocracies. We already see it in the kind of surveillance state that is possible with today's technology. But if you think of the extent to which AI can make individualized propaganda, can break into any computer system in the world, can surveil everyone in a population, detect dissent everywhere and suppress it, make a huge army of drones that could go after each individual person. It's really scary. It's really scary, and we have to stop it.
But again, is that something that you feel governments aren't paying enough attention to?
I mean, I think it's fair to say that obviously different countries think of themselves as having geopolitical adversaries, but the specific focus on we don't want autocracies to get this powerful technology, and we should have targeted policies. Like, we don't need to fight them. Like, we just need to not sell these chips. I think there's not enough focus on that.
I want to talk a bit more about Claude, because I think it's fair to say it's having a real moment. I mean,
it's having a moment.
It is having a moment, and we recently reported on how engineers and regular users are getting Claude pilled. And I just wondered how you feel about the state of the business today versus a year ago.
Yeah, I mean, this is one of these things that's been, the growth of the business has been fast, but kind of on the same smooth exponential curve as the technology. So we have this revenue curve that in 2023 went from 0 to roughly 100 million. Went in 2024 went from roughly 100 million to roughly a billion. 2025 went from roughly a billion to roughly 10 billion. Not exactly; these are rounded numbers, but that is roughly it. Through that, if you go on Twitter, every couple months it's like, oh my God, Anthropic's changing the world. Oh my God, Anthropic's totally destroyed. Just the excitability of the moment. But we just watch it, and we watch this curve. It's fast. It's constantly progressing. It's given us confidence. We never know for sure if it's going to continue. It might not. But that has been empirically what we have observed the whole time. And then there are these moments where, even though the curve is smooth, there's a breakout moment. And so right now, I think there's a breakout moment around Claude Code among developers. This thing about being able to make whole apps and doing things end to end. Again, that advanced gradually. But with our most recent model, Opus 4.5, it just kind of reached an inflection point, right? Where the improvement was gradual, but it's just like you boiling the frog. You see the gradual improvement, and then there's a specific point at which suddenly that's the point people notice. I think the second thing that has maybe accelerated that further is we looked at Claude Code, and one of the things we noticed is there were a lot of people inside Anthropic and outside Anthropic who were not technical, but who realized that Claude Code could do these incredible agentic tasks for you. It couldn't just write code. It could also organize your to-do list, or plan your projects, or organize your folders, or process a bunch of information and kind of summarize. So the idea that not just a chatbot but agentic tasks were needed. non-technical people were realizing it, and they wanted it so much that they were wrestling with the command line, right? Non-technical, they have no reason. If you're not a programmer, it's such a terrible interface to use if you're not a programmer. But people were going through and using it anyway. And so I looked at that and I said, that looks like unmet demand. And so we used Claude Code again in like 2 weeks, to make basically kind of a version with a better UI that's customized for tasks other than code. And we released it, and within like a day it had like most of the metrics on it were like 4 times as much as anything we'd ever released. So those are the 2 moments. I don't know that these are new capabilities, but there was just one of these kind of consensus moments where people got really excited, and it's driving adoption really fast. I think people are catching up to what the technology is capable of because it's reached a certain point and because we built interfaces that have made it accessible.
Can you tell us a bit about how you personally, in your life, your family life, use agentic AI?
Yeah. So, when I'm writing like, an essay or something, or like, things I say in front of the company, I feel like a fair amount of my job is writing. And so I kind of I have Claude, come up with sources, help me with my writing, that kind of thing.
And then obviously you're having this great moment, and I think it's widely expected that you're going to IPO this year. Can you tell us a bit about your plans for that?
Yeah, I mean, we don't know for sure. We don't know for sure what we're going to do, and I would say we're more focused on just keeping the revenue curve going, making the models better, selling the models to people, warning about the societal impacts and bringing the good societal impacts. So that's kind of the highest. That's kind of the highest priority right now, but I'm not saying anything novel if I say that this is an industry with very high capital demands, and that there's only so much at some point that the private markets can provide.
So another model that's absolutely having a moment is Gemini, and
Yes.
It sort of surged to the top of the App Store recently, and OpenAI declared code red, and so everyone got very excited about that. Do you worry about your ability to compete against Gemini, given the sheer size of Google?
So I think this is another place where just being different helps. So the enterprise strategy, Google and OpenAI are fighting it out in consumer, right? It is existential to both of them. Existential to OpenAI because that's their whole business. Existential to Google because they have the search business, and that's what's being disrupted by this. So they need to replace themselves and fight the disruption. So that's always their first priority, and they seem much more focused on that than kind of operating in the enterprise. It's been great to see what Gemini is capable of in consumer. I think they're going about it a different way. I was just on a panel with Demis Hassabis, who leads research at Google. I think he's a great guy. I've known him for 15 years, so I'm rooting for him.
You talk about differences. One difference is, I believe, is that Anthropic doesn't have the ability to generate videos and photos. Do you see that as a potential weakness?
I think for enterprise business, there's not really a demand for like, photos of, the cats riding donkeys or, whatever consumer video people want. There's maybe an edge case around like slides and presentations, but if we ever need it, we can just buy them, we can just contract a model from someone else. So, I don't know what will happen. I don't know what will happen in the future, but I at least don't anticipate needing this. And I think there are problems associated with this. Like, I think we look at the amount of short form video out there, like a lot of it's fake, a lot of it's pretty addictive, a lot of it's slop. Not to say that all of it is bad or that necessarily doing it means you're bad, but it's not a part of the market that I'm like, tripping over myself to get involved in.
You mentioned that you were on a panel with Demis Hassabis, and when we were chatting earlier yesterday, you said something that I thought was very interesting, that scientists are approaching the AI era, or scientists who are leading these big AI companies are approaching the era differently from sort of tech entrepreneurs. Can you say a bit more about what you mean by that?
Yeah, well, so, when you think about this technology, it's really the intersection of research that has been going on for many decades, much of which was academic in nature until, a decade and a half ago. And the kind of scale needed to, develop and deploy these technologies over the last decade and a half, which has only come from the large scale kind of internet and social media companies, right? They have the infrastructure, they have the cash. So we've seen a world in which some of the companies are essentially led by people who have a scientific background. That's my background, that's Demis's background. Some of them are led by the generation of entrepreneurs that did social media. And I think that's very different. That scientists, there's a long tradition of scientists thinking about the effects of the technology they build, of thinking of themselves as having responsibility for the technology they build, not ducking responsibility, right? They're motivated in the first place by creating something for the world. And so then they worry in the cases where that something can go wrong. I think the motivation of entrepreneurs, particularly the generation of social media entrepreneurs, is very different. The selection effects that operated on them, the way in which they interacted with, you might say, manipulated consumers is very different. And so I think that leads to different attitudes.
Now we've been taking some questions from readers who submitted their questions online, but before we do that, I just wanted to ask you one more thing, which is that, again, big picture, tensions are running very high at the moment between the US and the EU. Do you wonder about how that might impact how you operate your business should things escalate?
Look, I mean, we have always, we only speak for ourselves. We've always thought of ourselves as kind of our own thing. And independent, right? We don't go out of our way to be for or against anyone. But when we disagree on policy, we say so. When we agree on policy, we say so. And we really keep it focused on AI. And so, I haven't seen any reluctance in folks in other parts of the world to work with us, right? We're our own thing. We're providing AI models. We try to do that responsibly.
I mean, there's been a lot of talk this week about AI sovereignty. I'm not entirely sure what everybody seems to have a different
I don't know
definition.
what it means either.
Oh, you don't have your own definition. Good. Okay. Well, look. So, we have solicited questions from readers online. So I'm going to start now with one from Trevor Loomis. And his question is, what is the single most important technical breakthrough still missing to make frontier AI reliably safe and controllable in real-world deployment?
So I think we need to make more progress on mechanistic interpretability, which is the science of looking inside the models. One of the problems when we train these models is that we don't know, you can't be sure they're going to do what you think they're going to do. You can talk to the model in one context, it can say all kinds of things. Just as with a human, that may not be a faithful representation of what they're actually thinking. If they tell you, I'm doing X because Y, they might be doing X for a completely different reason. They might be lying about doing X. Like, we're very used to these problems with humans, but they exist with AI as well. And so any kind of phenomenological testing or training, we can't be certain of. But similar to how, you can learn things about human brains by doing an MRI or an X-ray that you can't learn just by talking to a human, the science of looking inside the AI models, I am convinced that this ultimately holds the key to making the model safe and controllable, because it's the only ground truth we have.
Right. Okay. I have another question here from Jim O'Connell. How will AI affect current K-12 educational achievement gaps? Very practical question there from no doubt a parent.
Yeah. So, there's kind of the short-term stuff about, people using AI for cheating, which I think is, problematic. But, in relative terms, okay, fine, you can have a kind of a different way of teaching using AI, and we've thought about that. We've released versions of Claude for education that are kind of designed around that. But I think the harder problem, behind that is, okay, what skills are we actually teaching in the world of AI? What does education look like in the world of AI? And it's not so easy because the disruption is broad, and we don't, if someone asks me what career should I go into, the uncomfortable truth is I'm not sure. I can't tell the direction that it's going to go yet. I will say that I think we should go back to some concepts that we had earlier about education. Like we've had a very kind of like economically inflected, almost mercenary notion of education. And I think one of the things that we should do is we should maybe move away from that notion back to the idea that education is designed to shape you as a person, is designed to build character, is kind of designed to enrich you and like make you a better person. I think that's actually a safer foundation for education in the future.
That sounds. I'm rather envious of the kids who are yet to be educated. It's the kind of education I think we'd all have liked to have. So to be fair to everybody in the room, then I think we've got time for one question. If anybody would like to ask a question, yeah. This lady here. Yeah. No. Here's the mic.
I wanted to ask, from a point of view of the AI labs, what kind of responsibility do you hold when there are economies, countries, and people that are being left behind? Would that expand into structurally involving them, slowing down, or actually making sure that they're not being left out?
Yeah, I worry about that on a whole bunch of scales. And it's not just country versus country. Certainly I worry about the developing world versus the developed world, where sometimes the developing world will get passed by technological revolutions. But I also worry about divisions within a country. It has occurred to me as I've looked across our customers, as the startups are so fast to adopt AI, and the traditional enterprises, because they're bigger, because they do a specific thing, they move much slower. And we can see it in our economic data. We can see the diffusion of the technology from states within the US that adopt it quickly and states that move slowly. It is diffusing, it's getting out there, but there's no question that there's a differential here. If I were to describe the nightmare, and then I'll just try to describe some, what I think of as the solutions. The nightmare would be that there's like this emerging zeroth world country of like 10 million people that's like 7 million people in the Bay, in like Silicon Valley, and 3 million people kind of scattered throughout. That is kind of forming its own economy and is becoming decoupled or disconnected, right? Maybe the 10% GDP growth looks like 50% GDP growth in that part of, like, this technology is so crazy it can pull things apart that way. I think that would be a really bad world. I would almost say that was a dystopian world, right? And we should think about how to stop that. There are, a number of things Anthropic is thinking about or doing. One is, as regards the developing world, we are starting to do a lot of work around public health. We've announced stuff with, Rwanda Ministry of Education. We're doing a lot of work with the Gates Foundation. I wrote about this in Machines of Loving Grace. It would be really great to get these fast economic growth rates, which in theory should be even faster because it's catch-up growth, in the developing world that I predict we're going to get in the developed world. Within countries, we need to think about, how not to have a part of the world that just kind of decouples, right? How do we get the economic growth to Mississippi that is coming to this contained area of Silicon Valley? And so, there we've done work around kind of economic mobility and economic opportunity. But I think both of these, again, are going to need to have some involvement of the government. We're going to find that ideology will not survive the nature of this technology. It won't survive reality. The things I'm talking about, while you could today say, oh yeah, they're like politically coded in some way, they're going to become bipartisan and universal because everyone will recognize the necessity of it. Just mark my words. We come back, if not next year.
My name is Farhan Thaur. I'm the head of engineering at Shopify. And I want to spend some time thinking through this question, which is, with AI coming and doing so many parts of the jobs of engineers, I want to explore, what is our job now? Because really, things have really changed, especially for engineering, but across all of R&D and even actually for other disciplines as well. And so I want to explore this question. But before we explore this question, I first want to take a little bit of a moment of silence. This tweet really hit me hard. This is the culmination of all of the software that we have come to use in all of our lives, including many of you, me too, that we wrote character by character. And it's amazing to think that everything up until now was written this way. So, moment of silence, a little bit of crying maybe, because it was how we did things in the past, and not really how we're going to do things in the future. And I want to explore what has changed. And if you look at the SDLC, the software development lifecycle, what you'll notice is that where we spend our time is moving. So if you look at the chart on the left, you'll see the majority of time was spent in coding. You, of course, spend time planning and verifying and testing and maintaining, but a lot of the big bulk, that big blue box, was the coding step. And what's changed when you look at the right is that the coding part has changed dramatically because you're going to spend more time using tools to plan and analyze. You might be spending your time validating what's coming out of the AI tools, but that coding step is very different. And there's two kinds of things to think about in that coding step. There's what's on the screen there, which is like parallel coding. So this idea of I'm going to break my tasks down into subtasks, and then within those subtasks, I'm going to have agents act upon those, and then I kind of come back and consolidate and do some kind of validation. But there's also this notion of sequential, very heavy, like critique loops. This idea of I'm going to really pair with one AI, I'm going to do something in a deep way, use an extra high or reasoning model. I'm going to have potentially another model come and interrogate that. But again, you're the one not necessarily writing the code. You are working with an AI agent and you are trying to plan out how to build something for your end customers. And so things are changing and how you spend your time is changing. Hence the question of like, what is our actual job? And it turns out your value just changes from the person who typed character by character all of those commands into your programming, your IDE of choice and the programming language you chose, to these other things: taste, judgment. When should I build something? Why should I build something? What should I build? How do I think about the architecture of what I'm building? Companies famously think about things in different ways. At Shopify, for example, we have a monolith. We try to build things into the monolith and we try not to break things down into sub microservices. Other companies might choose it differently. How does that fit into your workflow? But of course, understanding the problem, spending a lot of time thinking through problems with your customers, also thinking through the possible set of solutions. We have this line inside Shopify where we talk about when someone brings something to us, we might say, that's cool, so it works. How did you choose this solution among the 10,000 possible right solutions? How did you land on this green path solution? And then of course, learning. A real part of building software and actually working with customers and inside your teams is the learning process. We actually have a funny story about this. Pre-LLMs, I had a pretty large team, about 50 engineers working on one of our projects, and they spent 18 months building out, in this case, like something for our merchants. And we were just about to launch it. We had a famous Toby review. Toby's our founder and CEO. And we walked through the architecture, we walked through everything we built. We showed it to him, he's like, this is great. We should launch it. And right when we were walking out the door from the meeting, pre us being remote, he stopped and he said, hey, actually, one question. If you could start over, how would you build it? And the team kind of stopped and they're like, well, and then somebody went up to the whiteboard and said, well, knowing everything I know now, we would have built it this way. And he described a completely different and simpler architecture. And Toby said, well, why don't you build that? And literally what happened was we pivoted and he said, just delete what you did and start over, because what he was trying to show us was the learning was the collateral, not the code. And so what we did was we deleted that. We didn't actually delete the code because that's super hard to do, but we came up with this way to actually use what we learned, meaning we were allowed to look at that code but not cut and paste it, because that is the natural tendency. And we rebuilt the system in 3 months. And what happened was we had a much simpler, elegant solution because the learning was the collateral, not the code. And so what's happening now with the AI changes in AI in terms of workflow and SDLC is the bottleneck. I don't know if folks have read this book. It's a very good book, a fictional book about a guy in a factory, and he's trying to optimize various stages in the factory. And what happens actually is that he goes to fix a bottleneck, and what happens there is that he solves the bottleneck there, and then he realizes, oh my God, I'm looking at this workflow, and another bottleneck has appeared. And so then he goes and fixes that bottleneck, and guess what? Another bottleneck appears. And so what's happening is he is optimizing the factory and he is finding things that are bottlenecks and then turning them into not a bottleneck, and then he finds something else. It's exactly what's happening right now. The AI step of writing the code is moving the bottleneck to other parts of the SDLC. And so as you're spending time playing or validating, or in this case, writing code, your bottleneck is going to move, and that's fine. You're just going to find out how to resolve that bottleneck, and guess what? You'll find another bottleneck. And the same thing's going to happen over and over. But it's a very good book to read. And again, it's going to go back to what we saw in the last slide, is your taste and judgment, and you still bring a lot of value to the process. It's just a different bottleneck. And so why do we care at Shopify? Like, why am I talking about the SDLC? Why am I talking about AI? Well, it turns out we actually power a lot of the commerce infrastructure all over the world. We spend a lot of time thinking through how to build things in a way such that people can build on top of us. One mantra we have at Shopify is we always try to build infrastructure. So one example, if I could build a feature in 2 weeks, or I could build infrastructure in 2 months that allows me to build that same feature in 1 hour, I will always choose the latter. That means we try to focus on infra as the way to enable our developers and our ecosystem of developers to build on top of our infrastructure. And the reason we do that is because we believe that it's unclear what's going to happen in the future. And if we build the infra, again, I can build that feature in an hour on top of it. Who knows what else other people can build on top of it? So that's how we're focusing. And now what's funny is I gave you that example, but with LLMs, it might be possible not to have to make that trade-off anymore. If I have my problem defined well enough, do I have to actually make a trade-off between 2 weeks and 2 months? Maybe they're about the same, because the clanker, which is a term that Toby likes to use, can write all the code. I don't have to think through that trade-off of like 2 weeks versus 2 months. And here's some stats just to show you that we are at scale. We try to spend a lot of time optimizing our infrastructure as well. Performance matters a lot, simplicity matters a lot, resiliency matters a lot, availability matters a lot, and you can still, of course, get all of these things using AI to write your code. It just means, again, the place where you spend your time is going to move. Now, our journey in AI has been going on for a while. We were the first users of GitHub Copilot in 2021. That's a year before ChatGPT. I mostly bullied the CEO of GitHub to give it to us. And that allowed us to be in this age of autocomplete, if you folks remember that, where I would start writing a line of code and then it would autocomplete the remaining line, or I would write a comment inside of a file and it would just fill out a function. This idea of like pairing with the AI, right? This ability to go back and forth and let's try to build something together. We launched features using ChatGPT right away. And this was really the couple of years of the AI centaur phase, where you have like a brain and an LLM and you bring those two to work and together you build something. And of course, what happened in 2025, last year? Toby dropped what we call the tweet heard around the world, which is that AI is going to be a baseline expectation for employees at Shopify. What was funny about this tweet was not that it was first an internal memo and then it became a tweet, was that CTOs and CEOs would text me after this came out and share with me their own version of this same message inside their companies. Because what they wanted people to understand was that we want you to understand how to use this tool. We want you to be AI reflexive. What does that mean? AI reflexive means we want the distance that you travel between running into a problem and reaching for AI to be very small. How quickly can you reach for AI? How long does it take you to get stopped and then go, oh, hold on, let me pull this in a way that I can quickly move through AI? And so we spent time thinking about AI reflexivity at Shopify. We wrote articles, we started to share different ways in which companies, including ours, could use it in various disciplines, not just engineering, not just product, not just in R&D, but across the company. And we had lots of examples of how to do this. One of the main ways I brought AI reflexivity to Shopify was via Cursor. We deployed Cursor in 2025, and I quickly ran out of Cursor licenses. We're a company of about 8,000 people. I bought 1,500 licenses, and in the first week, I ran out of all of those licenses. And I think the most interesting thing that I learned, and also I shared with Cursor, was that it wasn't the typical disciplines that were using AI. So I thought right away, it would be engineers, product, data scientists, maybe designers. Instead, what I saw was finance, HR, sales, marketing. They were using Cursor as a way for them to get a window into these agents. Even though they weren't looking at the code, they were looking at using this as a way to kind of interact with their backend LLM. And so it was really interesting to me to see this happening. And of course, I procured more licenses and more licenses until, by the way, almost all of Shopify was using these tools. Today, we have a huge set of tools, including Cursor, that people use. They use Pi, and they use Claude Code, and they use Codex. And we even have an internal tool called River that we use. That it's like an agentic substrate across the whole company that you can ask it questions, it can write code for you. but it just shows you that people have choice. And our first step in kind of getting to that AI reflexive moment was literally just dropping cursor. That line shows you when the internal memo was dropped. So for those of you thinking through in your companies, like, can a mandate like this change behavior? Literally Toby's memo, and like you see everything go up from there. It made a huge change in how Shopify thinks about things. Not only did we see actually cursor usage and people adopting these tools, we saw real use cases. The support team built a tool called Scout, which allows you literally to ask it questions about the feedback we were getting from our support teams, and now our product management team uses it all the time. You can go in any day and see like what are the top merchant frustrations. We had customer success teams building out like monthly business reviews and quarterly business reviews using Cursor. It was a real way to get information and insight to their customers. Finance built forecasting tools. So it's really cool for us to see how not just engineers were using what we had built. The other thing I really wanted to change was the culture in the company at the same time. In 2024, we had 75 interns at Shopify, and in 2025 and in 2026, we have 1,000. The reason to bring the interns for work was not for charity. You know, some people are like, oh, it's community service, bring interns, and you know, it's like good for them and it's a good experience. It was the opposite for us. We wanted them to come in and teach us how to work. Think about the interns and the folks in college these days and early talent. What percentage of their life have they been with AI? This year, 2026, the graduating class had their entire college life having ChatGPT or another tool. And so these folks, we wanted them to come to our offices and question everything about how we work. Why do things work this way? We wanted their hunger, their intensity. We wanted to change the culture in the company. So 1,000 interns came in. We ended up hiring a lot of them as well to come work full-time with us. But it's a great way to kind of kickstart your company and make a cultural change. Not just the mandate of AI being reflexive, but also changing the culture of the types of people that came into your company. And again, the key part for me here, this is like literally my tweet, was the AI Centaur moniker. The idea of human plus LLM together can build something better. And I really like this term, AI Centaur. Like I mentioned, we had it for a few years, 2021 to like 2024, 2025-ish. And unfortunately, it didn't last as long as I wanted. It was like this amazing time when we could like pair with the AI, and that the AI still really needed us to like talk about like and give it advice on code. And as you know, in December of 2025, it all went away. Why? Well, people call it the Opus 4.5 moment or GPT 5.2 moment. This is where a lot of the world's top engineers during the Christmas break said, I think the LLM is better at coding than I am. And so this whole notion, and this is again, the ethos of an engineer and being like, oh my God, my job was like to write code, and everything about my life and my work is about typing in character by character, the thing that the machine will turn into machine code and execute for me. To like, now I'm gonna be like the AI steering person. Because when the LLM is better at writing code than you should focus the bottleneck, which used to be writing code, to somewhere else in the pipeline. And so this was the big moment for us. And in, you know, this is again the clanker versus human. This is where you have to really step back and introspect to yourself. Where do I wanna spend my time? If the AI is better at writing code, should you write code anymore? Right, it's an open question. Are there times when maybe there's something specific that you're writing that the LLM won't be good at that you have to write code? Potentially. But I would contend 90+% of the code now at a lot of companies it should be written by AI because it's just better than you are. And in 2026, right after that December 2025 moment, we started changing also how we think about expectations of the company. The word token maxing became a noun because what's happening is people are just using tokens over and over. And because we had become AI reflexive at the beginning, we wanted to move away from reflexivity because we had the whole company now using AI to AI leverage. This ability to not only use AI for your work and to remove your toil and for you to focus on your area that you care about and that you can bring human value and judgment to, but also this notion of how can I brag about how lazy I am? This ability to be like, you know what? I just built this in 5 minutes. It would have taken me 5 months. And so we wanted to role model and we wanted to show people what's possible. We, of course, like everyone else, had a LLM leaderboard, right? This ability to show everybody, hey, look how many tokens I used, and I'm in the top 10. And we moved away from that to like a usage dashboard, which really, it does still show you what you actually, what your token spend is and how you value, how you can gauge yourself against your peers. But it's not focused on being on the leaderboard anymore. It's not focused on being in the top 10. It's focused about providing value. And what's interesting about it is you not only can see, of course, who's using the most tokens, or what disciplines are using the most tokens, or what seniority, or manager versus IC, or even area of the world they live in, but also who's using the most expensive tokens, right? Something interesting is this idea of like, hey, these people are doing like actual reasoning, and the tokens they use are more expensive per million tokens versus those people who are just using lots of tokens. We don't have any limits of tokens at Shopify. We do have circuit breakers. A circuit breaker really is just something to find whether you are you have a runaway agent, and we've seen this happen, right? You might try to introspect some large piece of code, or might give a problem that the agent might go off in a weird tangent, and what will happen is you'll get stopped. You'll get a Slack message that says, hey, we've stopped your agent. You used X dollars today. Are you sure you want to keep going? And people are like, yep, I want to keep going. And then we don't block you. You might say, nope, I don't want to keep going because actually you're right. I didn't think that this was going to take this much money or this amount of time, and I can stop it. But outside of that, we're still in this mode of like opening the tools and letting people use whatever they want to kind of accomplish their goals. Some things haven't changed, by the way, as we move to AI. I talked about some of the things that did change. This is something that hadn't. Parkinson's law. One of my favorite laws, right, which is basically the amount of time you give something is how long it's going to take. If I ask you for something by Friday, you'll give it to me by Friday. If I ask you for something for next Friday, you'll give it to me next Friday. And now what's amazing about Parkinson's law and AI is that everything has changed because the roadmap is no longer going to be 6 months. It's typically going to be like, why can't you finish it this month? Why can't you finish it this week? Why can't you finish it today? And this idea of like prototyping quickly and then taking that prototype and maybe showing something to a customer very early on because you've got these clankers writing the code for you. It's not as hard as you think, and you should really look at Parkinson's law again and pull all those roadmaps in. We have this saying that we can finally see the end of the roadmap at Shopify now because we've got these tools. What else is not changing? Learning. I talked about this before. Everything that we focus on is to learn as much as possible. The code is not the collateral. The learning is the collateral. You want to make sure that you are actively asking your teams, and I know some people talk about shipping every week. We talk about like learning every week. What is it that you learned this week? What is like unintuitive? What is like a secret that you believe that others don't because you looked at the data, you've tried and prototyped something, you put something in front of a customer. What is that you've learned that allows you to make a different decision next week? This hasn't changed. I love this picture. This is what I got when I asked the AI to create a picture for pair programming. Makes no sense, but I think it's funny because literally it's like, this is what pair programming is to me. I'm like, well, not on one keyboard, but on multiple keyboards. But pair programming hasn't changed. There's going to be things that you learn with another human in front of a computer, along with an LLM, that you wouldn't learn with an LLM alone. And yes, you can use these clankers to write the code, and you're going to learn some things, but having another smart human and working together at the planning stage and at the validation stage, and of course, the coding stage, will allow the learning to increase. And again, don't forget, learning is the goal. This is a real picture of pair programming. 2 people, 1 computer, typically could be 2 monitors and 2 keyboards, but the idea is 2 people working together against the same goal. And yes, in today's parlance, they will have an LLM also. This is one of my favorite pair programming quotes, not to make this talk about pair programming, but the idea is that it's not lines of code. It's never been lines of code. Anytime I talk to executives, they're like, wait a sec, if I got 2 engineers, like they're going to write less. I'm like, yeah, hopefully even less than that. The whole point is not lines of code. And I think it's funny when people look at like token maxing or lines of code to try to figure out if teams are productive. And so if you can't use those, what can you use? So we have a bunch of things that we've noticed over time by looking at the Shopify ecosystem to see what we are noticing as things that potentially are interesting artifacts, but none of them, even the whole set, could be used to identify whether we're efficient or not. PRs per engineer are up. That's probably not a surprise. I think everyone's seeing that across the industry. We're seeing the complexity of PRs going up. So each PR, yes, the numbers are going up, but the complexity of each one is also going up. We're noticing the project duration is going down. So we have a product management system, and we can see, based on no other changes, that actually the duration of projects is shortening. So we're attributing that to AI as well. And then more importantly, the ambition of projects is going up. The things people are attempting, the things they're trying to bring to our customers is going up as well. And it's actually causing us to be more ambitious in how we think about the problem. We still like to do weekly demos. We think this is a great way. If you're always wondering, when I talk to executives, like what's the best way to gauge engineering velocity? Weekly demos. It's the best way to see what's going out to your customers. And then don't confuse the map with the territory. This happens to me all the time. An executive vibe codes something and shows it to you like, look how easy it is. I built this thing, and why can't you just deploy this production? A prototype is not production. I see this all the time. Don't forget I have a CEO who codes. He will say the same thing to me. Wait a sec, I just built this thing in 5 minutes. Why did it take the team a month? I'm like, because the prototype is not the production level quality of code. Still true. And has not changed. But prototyping is an amazing way to get feedback and to try things out. We try really, really hard to delete the prototype code or like don't use it because it's really a green pathing exploration exercise versus actually the code you can use in production. Here's an example. I had an intern delete 6 lines of code and save over $600,000 per year in our infrastructure. So tell me which of those metrics on the previous slide would have showed me that this intern is awesome? None of them, right? I actually don't even know, but I'm pretty sure this intern did many more things that term instead of this, and it would have been fine if they did this one thing. So there's really no way to manage by spreadsheet. So if you think you're going to try to manage by spreadsheet because you have AI, good luck to you. So I'm going to go through like 5 things that we talk about at Shopify as how we work, and so people can kind of get a sense, and I'd love to talk to folks after about what they're seeing. 1, model selection. We still only allow our engineers to use the largest, most expensive models. We let them only use Opus 4.5 or GPT 5.5. We don't, or Gemini 3.5. We don't let them use a smaller model because we believe that the human time is worth more than the clanker time. What that means is, if a human used a smaller model and a small bug was introduced, it would take them many, many hours to find it versus if they just use the bigger model. So as the bigger models come out, we use them. We don't let people use smaller models, at least in engineering. 2, the bottleneck is code review. You probably already thought about this when I came up with that bottleneck slide. Lots of code is being generated. How do you review it all, right? Let me show you the 4 scariest letters in the human language. Every fucking PR says this thing, and then it might still have a problem in it. It might still cause a live site incident. Like, it's insane. And so if you thought your current process is working, and you're like, I can't let an AI look at my code, look at these letters. Your humans were not looking at the code. They were not good at this. So you should do something else. And so we use accounts, and I'll show you a slide on the Council of LLMs, but we use lots of other things using AI tools to actually help figure out whether these code artifacts should go to production or not. Is it perfect? Of course not. Were the humans perfect? Of course not. I have people complaining to me now who say, oh my God, it takes an hour for the AI LLM to review my code. I'm like, before the LLM, didn't it take 24 hours or 48 hours for a human to give me the LGTM? Who cares? The LLM is better. The LLM is going to be more accurate. Is it 100% accurate? No. Is it better than humans? Yes. Here's an example of like what a council of LLMs looks like, right? This is like, fictional, but like the idea is that we have different models to having different tasks, and they look at different parts of the code as it goes through and look for different things. Like you can see accessibility here. They're looking for other things. And we use all of these judges to be like, should this code go to production or not? Should I send it back with some commentary? Responsibility. We do not let AI take responsibility at Shopify. You get to work with an LLM. You get to have it write as much code as you want. You, of course, do validation, but your name goes on the PR. You might also tag your LLM. Cool. But it is not about the LLM. It is about you. Responsibility can be shared, but it cannot be given away. Your name on the PR, your PR going to production. This one is an interesting one. How to think about hiring. So we have not, the shrug emoji there is because we have no idea how to hire for AI. I don't think anybody does. I don't even know how, actually Cursor famously didn't allow you to use Cursor for your interviews, so I don't know what Cursor's doing now, but we are definitely still trying to figure this out. But I like this model, by the way, which is an interesting model to kind of think through the problem. I went to Waterloo. My first year, I did a math degree. We were not allowed to use a calculator. So the whole first year was no calculator, and then second year we got a calculator. It forced me to learn everything by hand. Everybody learned everything by hand, and then you can introduce the calculator. So AI is kind of similar. If we want people to understand the underlying parts of AI, we want them to be able to work without AI. So that's number 1. Give them a problem they can't use AI on. Number 2, AI optional. So maybe I can't actually use AI, or I'm sorry, maybe I can't do it by hand, but maybe I can use AI. So you can optionally pull it in if you want. And then lastly, AI mandatory. I'm going to give you a problem so large, not enough time, and now you have to wield this tool. And I think when you look across all 3 of those, you kind of get a good sense of if somebody is good across all 3 of those. The thing it'll miss is like the savants, right? This is kind of like the chess player who like just makes a move and it says it feels good. There's going to be people like that who can just use the AI and be like, I don't understand code, but I can wield the tool in a way that gives me amazing results. And then lastly, I think the funniest thing from executives is like, oh, can't I make my dev team smaller? It's like the funniest thing I hear, like, oh, we have 100 engineers. What if we just had 10? I'm like, that's so fucking unambitious. Like, we think about the other way. I'm like, we have 3,000 engineers. Why can't they act like 100,000? That's literally the line we use. Because that is more ambitious. You can do more, right? Jevons paradox. You make something cheaper, you make something available, more people will use it. We're trying to solve the problem of entrepreneurship. Why aren't there more entrepreneurs? You think we're going to try to shrink? No, we think everyone can be more productive. There's even a funny blog post that came out. Somebody wrote this. The AI setup behind Shopify is 23,000 engineers. I'm like, I'm a quarter of the way there. It feels like we have 23,000 engineers to somebody. That's awesome. We only have 3,000. I want somebody to write the article that says, you know, the power behind Shopify is 100,000 engineers. All right, lastly, just to close. So some things have changed and some things haven't, right? The clankers will write and review code. Get over it. This is what's happening. You should try to embrace it. You will spend more time on other parts of the ecosystem, right? Of the SDLC, you're going to spend time on planning, you're going to spend time on validation. And you might change your seniority mix. I just introduced 1,000 interns. And by the way, I convinced Cloudflare to do 1,000 interns. And then I saw Matt Garman at AWS hire 11,000 interns this year. Everything's changing across seniorities. You might decide differently. You might decide to hire more mid-level. You might decide to hire more senior. And then what's the same? Taste and judgment. You're still going to have to care about taste and judgment, what goes to your users, and you're going to have more time to spend on it because you can go deeper into the problem. It still remains hard to gauge engineering performance. That's not going to change. You're not going to be able to manage by spreadsheet. You're not going to be able to be like all of a sudden be like, hey, we figured out the formula. Like for salespeople, it's just how much they can sell. Like engineers, it's how many what? I don't think there is a metric. And finally and importantly, learning still remains the goal. So for those thinking about running engineering teams, don't look at the collateral. It's not about the code. It's not about shipping. It's like, how quickly are you learning? Because you can use these tools to build whatever you want as quickly as you want. Thank you very much.
People love hearing about your coding workflow. I think right by now your idea of the prompt request rather than the pull request is very well socialized. And also you've been shocking people with just how you're spending tokens at OpenAI. So basically, people want to know how you ship and what do you do about agent waiting times? Like why is, you're spinning out so many agents.
I know, like I never imagined that this one picture of me would blow up so much.
Yeah.
Actually,
give some numbers just to align people.
I think, and there's times where I was running almost 10 sessions at the same time, especially when I used codecs with 5.0, 5.1. It was quite slow. I think, now I have to say we, it's still weird. We made improvements. They both make it faster, and then there's also fast mode. So by now, my typical workflow is maybe half of that, maybe 5, 6 windows instead of double, just because each loop is faster and like the area of work I think in and workers is pretty much the same. So I don't have to use split screen so much anymore. And I think we're going to move into a future where token will be faster and faster. So at some point, like this is not natural that you work on 6 things at the same time. But it's basically a workaround until tokens are faster.
Yeah. One of my interesting things of putting you next to Ryan was to see how the two of you kind of approach token maxing, basically. I'm curious what you think about the complete dark factory approach, right? That you don't even review code that goes in.
I think that's more and more doable. But also, when I dark factory in a way also means I come up with everything I want to build in the beginning, and I just don't think you can build good software in that way. Like, the way to the mountain is usually never a straight line. It is very curved. Sometimes you go a little bit off track, and then you see something new that inspires you. You find like shortcuts. Once you're at the top, you can find the optimal path, but you never walk like this. So at the same time, the first idea that you have about your project is very unlikely going to be the final project. But if I suddenly use the waterfall model again, that will be the final project. For me, that doesn't work for me. Like I build steps, I play with it, I see how it feels, I get new ideas, my prompts change. So to me, it's a very iterative approach. So I don't see how you could fully automate that. You can definitely build pipelines for certain things.
Yeah.
But even for PRs, you don't just want to build a pipeline that just merges PRs, because a lot of them just don't make sense. Like people will pull your product into all kind of directions, but if you automate that, the AI will very unlikely know what's the right direction. You can guide it. I have like a vision document that I tried some of that, but the bottleneck is still thinking. and like having taste.
Yeah, taste is very important. How do you define taste? This is something that, in my conversations with people, everyone understands taste is the moat, but nobody agrees on what good taste is. So I'm just curious to hear yours.
I think in this day and age, it's like the very low level of taste if it doesn't stink like AI, and you know exactly what I mean. You know, if something is just
So writing style, personality?
also UI. By now, you've seen so much agentic built UI that you immediately know if it's AI.
Yeah. If it has the color border on the left, right?
Yeah. I mean, for a while it was like the proper gradient, but much more. So I feel it's like a feeling. The same way as you can identify AI-written slop right away.
Yeah.
That's why I say it's a smell. Like even if you can pinpoint this, you will know. So that's probably the lowest characterization of taste. And then going higher up, because now so much of software is automatable, there's actually much more time you can spend on like the little details. I don't know, you know, like just when you run OpenClaw, you get like a little message that sometimes roasts people. Those are like the delightful details, I think, that you'll just not get if you prompt in a high level.
Yeah, one of my favorite tweets of yours is how you really put a lot of work into your SoulMD, and you open sourced your approach. And I don't think people worked on enough Soul until you came along. So I think that's really interesting. I have a podcast that I haven't released yet with Mikhail Parakin, who is the CTO of Shopify now, but he was the guy leading Bing, where Sydney was the original sort of unaligned chatbot that emerged. But I think people really have fun when your chatbot has personality. Your clanker, has different obsessions.
But it's also because the world changed, right? We had ChatGPT in 2023 and 4, and it was basically us having AI without understanding what AI can do. So we rebuilt a Google. So you have like a search field, and like you get a response, and you don't expect Google to have a personality.
Yeah.
But now that we moved more towards agents, like if I didn't think about in the beginning of WhatsApp Relay, and I just hooked it up to Claude Code, and then when I was on WhatsApp, I noticed that it doesn't feel quite right. Like even though like Claude Code already has some personality, it didn't really fit how people would write to you on WhatsApp. So that's how my whole iteration started. It was like, again, it's about taste, right? It doesn't feel quite right. It's like too wordy. It uses too many dots. My friends text different, and that's how I started working. They say, no, this isn't like, try to write more like a human.
I actually run a writing
like a lobster.
Like a lobster, yes. One of my favorite quotes of yours is madness with a touch of science fiction.
Yeah.
Right? Like that. This is how you run AI projects, and I think
not all AI projects, but specifically something like OpenClaw would have never been able to. It would not have come out of an American company, just because it would have been killed in legal long before it would have been released, because it just has some problems that we haven't really solved as an industry yet.
Yeah.
But now we have some mitigations and it's getting better. The models are getting a lot better. But I don't see how any of the big labs could have released that. There would be too much pushback and like not enough market proof that this is what people want.
Yeah.
So like it had to be done with someone
like you
outside.
Yeah.
That
sitting
like
in your
literally
house.
like when I built it in the very beginning, I was like, oh, what's the worst that can happen? Like it could exfiltrate my token, my emails. Nothing's in there that would like completely kill me. It could like upload some of my pictures. I was like, I guess the worst already online if you use Grindr. So it was like, okay, I can live with that risk. It would be uncomfortable, but it's like it's manageable.
Yeah.
If your company is very different, it requires a little different approach.
Yeah. By the way, his Instagram account, good follow, underfollowed. It's also has some good stuff. Okay, you were talking about WhatsApp, talking about Telegram, a lot of these text apps. Text apps are good. People are also looking for like the next form factor. People want like maybe the glasses, the earbuds. What is your sort of wish list in terms of having agents in your life?
I started on that actually already, but then I was just getting bogged down by all the people using it and just like the daily grind. But if you're at home, I want to be in any room, and you know, at Star Trek when you say computer, I want to like talk to my agent wherever I am, and it should just be able to like respond to me. It should know where I am. I have like little iPads in every room, and my agent can use the Canvas feature and project stuff on those iPads. So like, if I ask a question that is like easier to be answered by also showing me something, like it could use like the nearest display because it's aware of where I am. So the phone is just a very convenient input point, but I kind of want to like talk to it from anywhere.
Yeah.
Like, yeah, if I'm around and I have glasses, I should just like be able to like listen in and like project something on me.
But just ubiquitous, follow you everywhere.
I think, yeah, once we have...
Truly smart home, yeah.
Like, agents on your phone, but really you want ubiquitous agents, and then you want maybe, you will have your uppercase OpenClaw, your private agent. At work, you might have your, I don't know, lowercase OpenAI Claw. And then that claw should be able to like talk to your personal claw in a way that both your company and you are comfortable with. So that's kind of like the future where we need to work on.
Yeah. I just did a podcast with Mark Andreessen, who's a huge fan, and also have conversations with Andre Karpathy. Both of these guys are running OpenClaw to run their house. And I think OpenClaw for homes is like a kind of underrated, but like people are really discovering it. And my funniest sort of irony is that it's only possible because the Internet of shit means that most smart devices are terrible in security, which means OpenClaw can run them.
Oh, it's going to be able to work so much better in a few months when the models are getting really bad.
Yeah, they're very good. Okay, one security question about prompt injection. How do you want to solve prompt injection? Or what ways in which have you been thinking about the prompt injection problem?
Probably not enough yet. On the other hand, like the front-end models are really quite good at detecting all the cases where like just stuff randomly comes in from a website or an email is usually not a problem anymore. You mark it as untrusted content, very hard to exfiltrate you from that.
Yeah.
If I have unlimited access to your claw, I can bombard it with stuff, then there's still a chance.
You're gonna find a way. Yeah.
Then there's still a chance, but like for one of things, it's no longer the biggest problem. If you use, that's also why you know, this is probably the angle where like some people say, oh, Peter doesn't like local models. But then I see like people running like a 20 billion parameter model that just does whatever you tell it and is not trained to have any defenses at all. That's still problematic. If you run that and then you use a web browser or email, would worry me. That's why OpenClaw warns you if you use a small model. And I know people spin a whole thing like, I hate small model. I love that we support everything, but like you have to steer the regular user a little bit into a direction to make it harder for them to shoot themselves in the foot. Yeah, there is some ideas for prompt injection, but it's still a little bit away. I have more to announce there.
I think Simon Willison has been working a lot on this. I mean, he coined the term prompt injection, and the sort of dual LLM approach seems smart, and I'm not smart enough to figure out all the ways that in which it can be attacked. Like at some point, trust just has to be a thing, right? It's something interesting I found out from talking with Vincent, who's speaking next, is that you guys had to implement the same trust system that Toby Luca had to implement, which is you build reputation over time, and things with more trust gets more privileged access, right? And I think that makes sense.
That's at least part of the story.
Yeah. Okay, so those are more broader questions. What cool projects would you like to work on once you have more free time?
I mean, I wanted to work on dreaming, and now like my maintainers worked on dreaming while I'm there like.
While you were dreaming.
So
You
like
just shipped it, right?
Yes.
What is dreaming?
It's like a way to reconcile memories and like kind of create a little bit like a dream log. Go through like your session logs.
We found out from the Anthropic source code leak that they're also working on dreaming, right?
Yeah. I mean, I'm pretty sure there's like more companies working on that. But think a little bit like, how do we learn as humans? You experience a lot of things during the day, and then you sleep. And in sleep, your brain does like a garbage collect, converts some locally stored memories into long-term storage, and like drops others. And that's similar ideas that I think could also be very useful for agents. And then like what we shipped on dreaming is like a first little step in that direction.
Yeah, and it's related to the wiki thing that Andre has been talking about, where you sort of collect everything into a...
Wiki is more memory, but like everything kind of blends a little bit together. The beauty of OpenClaw is that we can just try stuff. You know, like everything what we worked on for the last month or so is that in the beginning it was a big spaghetti code base mess, and now like everything is an extension, a plugin. So you can replace memory, you can add the wiki, you can add dreaming, you can add, I don't know, your whatever crazy idea you have, and just make it your own. You don't have to send everything to a pull request because we are still completely overloaded on those. But it's more like Linux, where you just can install your own parts.
Yeah, and you are building what a lot of people think is the most consequential open source since Linux, which I don't know. How do you deal with that? How do you deal with the fame? What is a day in your life as the BDFL, effectively, of something like this?
Well, there's still a lot of coding. There's also a lot of...
By the way, in between sessions, he was coding. Back there.
Yeah, get token anxiety. You have to like, something has to be running.
You have to push the agents, right?
Yeah. Where it shifted a little bit now, it's a lot more talking and steering people in the right direction. You know, like, because there's a lot of things that we already learned in OpenClaw. So like part of my role at OpenAI is like to like help them not make the same mistakes again. And then at OpenClaw is like try out new things that seem exciting, and some might work and some might don't work. Enable companies to like build their own claw without having to fork away, but like making everything more customizable. Yeah, and sometimes I sleep.
Sometimes you sleep. Okay, great. I think maybe this is the last good closing questions. What skills do you want humans and engineers in particular to focus on developing in the age of AI?
Taste was a big one, but I already mentioned that. System design is still very important.
Yes, we talked about this in San Francisco. Yeah.
If you don't think about that, you will eventually slide yourself into a corner, right? Just by defining the boundaries. Like, the funny thing is, like, everything is in the clanker, but you still need to ask the right questions. Otherwise, that makes this a difference of like good code that comes out or like really bad code that comes out. And that's still where like all the knowledge you have, like how you build software, you can apply to steer the agent into something that is not slop.
Yeah.
And then I think a skill that is becoming more and more important is saying no. and that's something I had to learn as well, because even the wildest idea is just a prompt away. And usually this one idea is never the problem, but like this idea and this idea and this idea and this idea, and then how all of that fits together, that's the problem.
Yes.
So like, I think we're still bottlenecked on thinking and about like big picture thinking.
Yeah.
Because imagine the world from your clanker. Like you're being thrown into a code base, you might have an outdated agents.md file, but you basically don't know what DF this is, and you like, then like you tell me, hey, add user profiles, and you like somehow add user profiles and connect it to the two things you see, but you didn't see the whole system, right? And that's where a lot of those localized solutions comes, where like your project has like VARs, and it's our job to like help the agent do its best work by like providing them with like hints. Hey, you want to consider this? You want to look there? How would this interplay with this? And then ultimately you get like a system that actually is maintainable.
Yeah. Well, thank you for maintaining one of the most important software of all time, and thank you for spending time with us.
Thanks for having me.
Yeah. Hopefully you stick around and answer questions. Thank you.
I've heard you say that coding is effectively solved. You haven't written any code in 6 months. Sometimes I see engineers pushing back on this idea, and they say, look, coding is not only about typing, it's also about judgment and taste and critical thinking, and agents can still be quite bad at those. So what do you make of that critique? Like, are there parts of coding that remain unsolved, or is that, in your view, that's just has become something else?
Yeah, I mean, the critique is totally right. I think this is one of those things that just gets like kind of taken out of context. So, the full quote is coding is solved for the kinds of coding that I do. And like for me, like I work on pretty simple code bases, like Claude CLI, like the CLI is like a pretty new code base, like the desktop app and the mobile app, like these are pretty small, simple code bases. We have so many enterprise customers, like a lot of our customers now are like the biggest enterprises. It's not just like startups and indie devs anymore. It's like NASA is one of our customers. So it's like, they have really big, really complicated code bases. And so for them, like, it's not solved yet. Like, the model's still not perfect at it. It still makes mistakes. Its code isn't always perfect. And when you think about the kinds of stuff that engineers do, coding is a small percent of it. It used to be that it's like, if you look at my day, maybe like 50% of my day used to be like actually like typing code. But then the other 50% was like talking to users. It was brainstorming and coming up with ideas. It was like debugging and kind of just thinking through how something works. It was planning. There's just all these other things that engineers do that are not coding. So when I say coding is solved, it's like it's solved for the kinds of coding that I do, and coding is just a small subset of what engineers do. And you actually see this, for all the engineers at Anthropic, and I think more and more engineers in the industry. When the model does the coding, they're freed up to do all this other stuff that they actually enjoy doing a lot more, like
Right.
like talking to users and like figuring out what's next. And, Claude Code has been just 100% written by Claude Code for, over 6 months. That's true for a lot of things at Anthropic, beyond Claude Code. That's true for Cowork. It's true for a lot of other products. And we're starting to hear more and more customers like this. Like, I was doing a talk for the latest Y Combinator batch. This was like earlier this week. We did a fireside. And I used to ask at the beginning of every talk I do, raise your hand if you use Claude Code. Now everyone uses Claude Code, so I stopped asking that question. And so instead, the question that I asked is, raise your hand if 100 most cutting edge startups, but they're all small startups, usually it's like a few people, half the hands went up. And then I was like, okay, raise your hand if none of your code is written by, the model, and there's one hand that went up. This is out of a room, like a couple hundred people. Yeah. And then everyone else is somewhere between. They were like between 50 and 100%. So I think like coding is starting to get solved for like a bigger and bigger percent of the code that we write. Like our team is an early indicator of what's happening in engineering. Engineering is an early indicator of what happens to everything outside of engineering. And so we're starting to kind of see this shift, and it started 6 months ago. And it's like it's accelerating, and we're starting to see more and more hands go up when they ask like, is it 100%?
Let me ask about another fear that people have about a world where the engineers aren't writing as much code. The fear is that people's understanding of their own profession will atrophy, and that might be dangerous in various ways. You haven't written any code in 6 months. Do you feel like that atrophy has started with you? And how do you feel about it?
There's there's one engineer on the team, Lena, that was still writing like C++ on the weekends by hand just for fun, because she like still enjoys like writing the code. And I think there's always room for this. I think for me, this is part of like a much broader transition, and it's not about atrophy at all. It's just about like programming is always the thing that is in flux. Like my grandpa programmed in punch cards, like back in the Soviet Union, like 70 years ago. And for him, that was programming. Like there was no JavaScript, there was no, Python. That didn't exist yet. For him, those punch cards was like piece of paper. There's a machine that like punches holes in it. Then you feed it into this mainframe. It processes it. Like a few lights light up. And when you talk about programming, like that's what it was. And then, like before that, like, like the Apollo program, it was like there was a room full of people, like often like women, like doing math on paper, sometimes like by hand. That was called programming.
Right.
And nowadays, like this changed. Like programming became writing machine code, then it became writing assembly code, then it became like JavaScript and Python, Java, all these languages that people use nowadays. And now it's like changing again. It's now you talk to the agent, and it's actually I think about to change one more time, where you talk to an agent that talks to agents that does the coding. But it's just always changed like this. It doesn't feel like atrophy to me. It feels like it's like a sea change in the technology.
My feeling about it has been that, like, I'm sure that using a graphing calculator like caused some of my math skills to atrophy, but my solution to that is that I will just continue to use a calculator. Like, I'm sort of fine to cede some of that stuff. Now if over time the calculator becomes super intelligent and tries to undermine me in subtle ways, like that would sort of freak me out. But maybe we haven't like crossed that bridge quite yet. Let me ask about another criticism that I sort of feel like is in this realm, which is it seems like every time a new model is released, we'll hear people say this is really good, and then you check Reddit a few weeks later and they say the product has massively regressed. My sense that sometimes this is like a real issue caused by bugs. Other times it's just sort of a vibe. But I feel like people are concerned that because it's all just sort of AI generated right now, there isn't maybe sort of the same craftsmanship that we once saw in code. So I'm just curious what you make of these periodic backlashes we seem to see.
Yeah, it's actually sort of an open question what causes it. There's been a couple instances where it was real. And there was two that I know of, and we published like engineering, blog posts on the Anthropic blog about it. Because like if it's real, like we found it, we fixed it, and then we want to talk about it so people kind of understand exactly what happened. But I think in almost every other case, it's sort of like maybe it's like a honeymoon period where you kind of get used to the model, and at first it's magical, and then you kind of get used to it. Maybe it's something like that.
Yeah.
But I don't think it's really about craft, because the model's code at this point is just much better than the code I would have written. If you talked to me like a year ago, I would not have said that. I would have said the model is like kind of sloppy and like the code's not really good. You have to like triple check everything. It can make silly mistakes all the time. But that's just like simply not the case anymore. And again, it's just the model keeps changing. It's really weird because every other technology we use does not change this fast. But there's like if you tried the model for the last time, like a year ago, the model now is completely different. And so if a year ago you had to hand hold it and you had to triple check every line, now I just generally like let Claude do its thing. I ask Claude to double check the result. I ask Claude to like open the app and test it by itself. And then, while I do that, I have like, 15 other Claudes running that I've also asked to like do stuff like this.
Right.
But that's kind of what it is now. The code is actually just much better than what I would have written.
But let me ask you about your Claude Swarm then. You asked me earlier whether computers make me more productive. I think it seems clear that Claude is making you more productive, but it doesn't seem like it's actually reducing the amount of work that you're doing. And I think this is kind of like an important thing to dig into if we're curious like what AI means for jobs. Because, it sounds like you believe companies are going to need fewer engineers, and yet at least for you, like you're never running out of things to do. So like how do you think about that, like that question of it's making me so much more productive, I'm not working any less? Will there ever be a case where making me more productive actually means I'm working less?
Yeah, I mean, there's like a name of there's like some paradox. I forget what it was, but there's someone that named this thing.
Okay.
Yeah, I don't know. I think that it's actually really individual. There's some parts of it that where it's up to the company, because like depending on the business, there might be more need for people or less need for people. But I think actually a lot of it is individual preference. There was like like when the laundry machine was released. I'm gonna give like historical because for me, this is a crazy technological change. Like I need history to kind of anchor myself.
No,
So
I love
like,
it. I love the stories.
Okay, yeah, so this is just how I think about it.
Yeah.
So like when the laundry machine was released, I think the average person to do a load of laundry, it took like 5 or 6 hours, and you had to walk. There was some estimate of like 3,000 feet or something from one load of laundry. Because like the way that it worked was like you had to walk outside, and you had to like collect the logs and the coals, and you go back inside and you start a fire, you boil the water, then you take it out. you put in the laundry, you like scrub it on the scrub board, then you have to wring it out, and then you might have to like repeat this for like your entire family, maybe like every day. And it was just like a lot of work. And at some point, the laundry machine appeared, and it just took it down like a lot. I think it took like 3 hours off the time it took to do a load of laundry. And this was one of the factors that let women enter the workforce in mass. Like without this, like usually it was the women of the house, like not always, but usually doing this work. And then this means like you were just like stuck at home and you couldn't do anything else. But now it's like 3 hours freed up every day. And so like different people could choose how they want to spend this time. And maybe for some people the choice was, well, I just want to like hang out with my kids, or like I want to go like, you know, walk the dog or read a book or hang out with my friends. But actually for a lot of people, the answer was, okay, I'm ready to enter the workforce. Like I want to go like work at a factory, or like I want to go work an office job. And because the time was freed up, now you have this choice of what you want to do with this time. And I think it's kind of similar right now. It's like, it's similar for any technology. It gives you more choice.
Yeah. A couple of last questions about the software engineering. I've been asking all of our guests if a 22-year-old just finished their CES degree this month and came up to you and said, okay, now what? What do you say to them? Like, is there an entry-level job that is out there waiting for them, or do they need to like think differently about this like first part of their career?
My advice would be, if you're a person that wants to work at a big company, or you want to work like at a company, you can totally still do this. Like there are entry-level jobs. There's a lot that you can do. But actually, if you're at all entrepreneurial, go start a startup. It's just like there's never been a better time in history to start a startup. Like it's just absolutely the golden age. It's like you and your agents can build a giant company. Like people are building like billion-dollar companies, and it's just like a few people. You know, like for Claude Code originally, it was just a few of us. And, you know, we have so many customers where they're building like really big businesses and just really amazing startups. And it's just like, you know, like 1 or 2 or 3 people. And one person with the right idea has so much leverage. I just couldn't imagine a better time to go and do it.
That's interesting, because I feel like a lot of the view that we get from the AI world is like, you know, model capabilities are advancing so quickly that like, will we even have companies in 5 years? But like, you think that, at least for the next bit, there's still plenty of room to start a company, get into business, make a product, all the rest.
At least for the next few years. I mean, if you really trace out the exponential, it gets really weird. I mean, there's like a version of it where like the idea of jobs kind of doesn't make sense anymore. The idea of companies doesn't make sense. The idea of software doesn't make sense. But, you know, as you trace the exponential, it just gets weird. But I think in the meantime, there's so much to do. And, you know, we're all just here kind of figuring out what the model means and what this thing can do. So might as well be one of these people that's exploring the frontier.
Yeah. All right. Last one on the engineering. If 3 years from now, do you think we will see more engineers, fewer engineers, or will it be impossible to answer because we just might not be calling them engineers anymore?
I think, okay, let's define it.
Yeah.
I don't think we're going to call them engineers, but if we talk about like people writing code or people like using agents, you know, like people using Claude to write the code, I think there will be 100 times more engineers than there are today. That's my prediction.
Wow. Okay. All right. Super interesting. Well, this seems like a good time to return to Claude Cowork, which you brought up earlier, and I know that you helped to develop. I would say this is the Anthropic product that I actually use the most now. I use it as a kind of editor on my columns. I use it to help me produce a podcast. I've been using it as a kind of financial advisor. Basically, you just create products, you add some skills, and it can kind of successfully imitate lots of different, roles in a workplace. Also, as a non-technical person, I just find the UI very intuitive to use because it mostly just involves like dropping documents, into a box. Talk to me a little bit about the road ahead for Cowork, and in particular, I'm curious whether you think it can solve for other jobs the way that coding is maybe now partially solved.
Cowork is just so exciting because we first started to build it when we saw people like abusing Claude Code essentially for things that are not coding. Like like someone like installing the terminal so that and like opening up their terminal, installing Claude Code in the terminal so they could do like their tax returns. And, like this is like crazy. It's like that's not what a terminal is for, but it's like amazing from a product point of view because like people really want this.
Yeah.
I think the journey the next few months is going to be figuring out like how do we make this work really well for people that are not engineers. And this is something actually kind of new for us because most of our team works on coding, and now part of the team works on co-work, and we're trying to kind of figure this out. For coding, it's actually pretty easy because the people building this are engineers, and so we just kind of build for ourselves, and it's really useful for everyone else. With co-work, one of the harder things has been it's useful for just like everything that's not engineering. It's like it's useful for accounting and finance, and also for legal, and also for like I used it to like buy like a clamming license so I can go clamming with like the state of Washington. I used it like I said to like book flights and like concert tickets. It kind of does all this different kind of stuff. And so how do you make sure it's actually really good at all this stuff? And so I think the biggest thing is like we use it all day every day. We talk to customers all day every day, and then I don't know, we just do the things that a lot of customers are asking for. So I would expect it to just like keep getting better at this stuff. I would expect it to keep getting better at running for long periods of time. And this is something that we saw for coding. Like a year and a half ago, Claude Code could run maybe like 30 seconds without me having to interrupt it because the model just wasn't there yet at all. It just would go off the rails after 30 seconds. And now, like I run Claude for just hours and hours and hours. And every night I have like, hundreds or sometimes thousands of agents that are just running 5, 10, 20 hours. And this is just how engineering is done now. And I think the same thing will happen with co-work. I don't know like what the kind of work is where you would want it running that long, but I think we're going to figure it out because I think people are going to start to like knock down the doors and demand it because like they really want this.
It's an interesting question to think about. Like, honestly, it makes me feel a little bit insecure because if you're like, Casey, like, what's a task that you wish Claude could work on for 20 hours for you? Like, I would sort of flail a little bit. It doesn't take 20 hours for me to like report and write a story or make a podcast. But, then again, I think once that becomes available, maybe I, figure something out. So maybe that's just sort of brings us back to the capability overhang that you were talking about earlier.
Yeah, I mean, in some ways, it's so hard to predict the future because this technology is so weird. But I think once you actually use the technology and like you use it every day, you kind of feel like what's what's missing because you feel it.
Yeah.
So it just becomes more obvious. I think if you asked me that same question like a year ago, like, would I have run an agent for 20 hours? I would have been like, no, that doesn't make any sense. I have no idea what I would use it for. But now I do this like all the time.
And, I suppose one thing that it can do, maybe that it doesn't today, is just like anticipate your needs, right? Like as it develops a better sense of who you are and what you do, as its memory improves, it can probably do a better job of guessing like, okay, like Casey, you got 4 more episodes of this podcast. You haven't booked, the final 2 guests. I'm going to brainstorm a list of those guests. I'm going to draft some initial reach out emails. Like I'll put them in your drafts folder. Let me know if you want me to send them. Like these are the sort of things that I could imagine, like a human a producer or coworker doing for me. And I can't imagine a world in the not too distant future where something like cowork is doing something similar.
Yeah. Maybe it also kind of depends like how do you define a task? Like maybe there's like a horizontal way and like a vertical way. Like maybe one way of thinking about it is like a task is everything related to design, or everything related to engineering, or everything related to like finance. But maybe like another way is like this kind of more vertical way. And like something that I experience every day now is I use Claude to do something. Let's say build a feature, and then Claude will like build the feature, it'll test it, and then it'll merge it, and then it'll kind of like launch the feature for me. Like just maybe something in Claude Code or something in Cowork. And then something that Claude started to do with Opus 4.7 is it started to become a lot more proactive. And the thing I've started to see it do is it'll launch the feature and then it'll be like, okay, great. I'm going to schedule a reminder for myself in 12 hours so I can like see what the user feedback is. And so if there's like any bugs, I can like go and fix that. And, this is something I would have had to do and like remember to do. And I probably, I might have forgotten to do it. And so like when Claude does this, it's just like delightful. So I'm like, okay, thanks Claude. Thanks for kind of like thinking ahead a little bit. So yeah, there might be a little bit more of that.
I also want to toss in a question about Claude Mythos. This model is not available externally yet to most people. What we have heard about it from you all so far mostly concerns coding and cybersecurity. But I imagine that some version of it will come out before too long, and it will probably be good at stuff beyond coding. So I wonder, like, in your opinion, is Mythos relevant to the jobs question? Like, does this feel kind of like another step down the road of like the jagged frontier being able to do more work?
Yeah, I mean, it's another point along the exponential. This one, I think, this one's a little further along than most of the jumps we usually make. This one is a particularly big jump. But yeah, it's like, Mythos was particularly strong with cyber and with coding, and maybe there's some future version of it that's, strong in other capabilities also.
Yeah. Well, as we start to zoom out a little bit and maybe talk about the implications of a world where more jobs are disappearing due to automation or maybe just transforming quite a lot. I think you've said in the past that you do think that this transition is going to be painful for a lot of people. And Anthropic is in a unique position here, right? Like potentially it will be a source of unemployment among software engineers or people in other jobs. Does the company have an obligation to those people? Is that something that the government needs to be paying attention to? Or what do we do about this world that seems to be coming into being?
Yeah, like I said, I think it's going to be mixed, like it is for any technology. There's going to be good effects and there's going to be bad effects, and we don't know the exact timing. We don't know the exact mix. Like you can just never predict it in the moment. I feel like I do feel this pretty immense obligation, just like as an engineer, that there's always more that we should be doing to tell people about kind of what's coming, make sure they're able to use the tools, kind of educate them and bring them along into the future. So I actually feel this very strongly, and it's something that like the team and I actually talk a lot about. I think that broadly, this is not a problem that we can solve. This is bigger than one company, and you actually really don't want one company to solve it because it could be the wrong solution. So I think this is a society-wide question. It's something that we should be talking about. It's something that we should be debating. And I think the thing that Anthropic is trying to add to the mix is we put out economic reports, we talk about policy, and we generally just try to make it really obvious what we're seeing so that everyone else can decide what we do about it.
Yeah. I mean, I do think the number one thing that has gotten people to take these issues more seriously is just improvement in the quality of models, which I guess makes sense, like when it's just purely at the realm of the theoretical, people have a hard time thinking through, okay, what do we do next? But then, once you see a computer use itself, for example, I think a lot of people have that moment of okay, it's time to develop a strategy here.
Yeah. Yeah, and this is I think one of the reasons why we build product at Anthropic. We're an AI safety lab. It's actually kind of weird to even build product. It's really not obvious why we should be doing that at all. But actually, one of the biggest arguments for building product, and this is actually a debate early on in Anthropic days, and one of the biggest arguments was we want people to experience it so that they can understand it, so that they can kind of play a part in figuring out as a society what we should do. But if you keep this technology locked away, so no one knows what it can do and no one can experience it, it's much harder for people to form a point of view about it.
Yeah, I also wonder if you've thought at all about the. Let me start that one again. Our most recent guest on the show is James Banyika from Google, who's kind of studied technology at the level of economies and whole societies, and he's really worried about what started out as a kind of digital divide. So not everyone having equal access to technologies like the internet or maybe a good laptop. And he's worried that that's about to transform into an AI divide. And it seems like the data that we've seen so far shows that the people who are getting the most out of AI are the ones already sort of near the top of the income ladder. From your perspective, does Claude Code make that better or worse? Who do you see actually using it and not using it? And are there efforts to try to, maybe get it into the hands of people who haven't always had access to these kinds of cutting edge technologies?
Yeah, so I think there's a couple programs to do things like this, to kind of just spread access, and Anthropic does this. I think the thing that I've been just continuously surprised by is the people that get the most value out of Claude Code and use the most are just not at all the people I expect most of the time. We just did this hackathon for Opus 4.7 release, and the people that won the hackathon are not actually professional engineers largely. There was one person that was there was an electrician, there was a doctor. There was a carpenter that used it to build an app. And we actually saw the same thing with our last hackathon, with the 4.6 hackathon. Before that, I think it would have been mostly engineers, but I think now the models are sophisticated enough that it's actually not even engineers a lot of the time that are learning how to like really harness them. And this is a thing that we're seeing at kind of big customers also. So like as companies think about how do you adopt AI tools, obviously you have to think about how do you do this kind of like business process change? How do you put Claude at the center? This is like the biggest question. And every company is approaching it kind of differently. One of the ways that I've seen work the best is you just give everyone tokens. You make everyone feel safe experimenting, and the ideas will come from the people that you don't expect a lot of the time. It's not actually the like super senior engineer that was like the most productive in the past. Actually, the best idea might be like an accountant somewhere in the corner of the org, or it might be like a GTM person somewhere in a different corner of the org that like built some amazing internal dashboard that just like sped everything up a lot, or like solved some important problem that like no one even realized the business had. So I think actually like this is the future, and like this is the thing that we're going to start seeing a lot more of, and it's going to keep being surprising. And so like yeah, it's important that people learn how to use the tools, because it's not necessarily the people that are the most productive and the best with the tools of today that are going to be the best with the tools of tomorrow.
All right. Well, we've talked a few times so far about how difficult it is to like think through what life is going to look like in an exponential. So I'm going to try not to ask you to predict out too far. But if we had you back in a year, how much of the world of, let's just maybe keep it to software engineering, will look very recognizable, and how much would look a little crazy to us from today's perspective? A year from now, is there a world where you think we do start to see some of that automation kicking into gear, some more big layoffs at companies that where they're citing AI as an example? What do you think we're going to be looking at?
I think there's going to be a lot of disruption in the next year. I think there's going to be a lot of big players that try to figure it out, and I think a lot of them will be successful. I think we're going to see some like traditional business modes go away. There's all these different modes that companies have, and some of them are here to stay, even despite AI. And then I think some of them are going to matter a bunch, less because of AI. So like a mode like network effects, that's actually like not going to go away. Like if you have like an app that gets more valuable with more people being on the app, it doesn't matter like who's building the app or whether AI exists or kind of is an important force or not. Like that's still like just as important. If you think about like scale economies, so like as you manufacture, the marginal cost of goods kind of goes down over time. There's like kind of a natural advantage your business gets from that, and I don't think that's really going to go away. But actually, other modes are going to go away. And so this is, for example, like switching costs. So like, you're on vendor A and you want to move to vendor B. Actually, Claude can probably just move you from A to B. And like the switching cost is not a giant mode anymore. Yeah. So I think businesses that depended on some of these modes that are going away are, they're not going to do well. I think a lot of them are going to figure out new modes. And actually, if you look at like all the big businesses today, like the biggest companies, they actually have a number of modes, because this is something they think about all the time. Like, how do we have a defensible business? So it's actually like not that new to them. And then I think, some companies are going to continue to do well. And I think there's just going to be, if I had to predict something that would be surprising today, it's that there's going to be a lot more innovation than we expect. I think there's going to be a lot of new ideas coming from not big companies, but tiny startups of like 1 or 2 or 10 people. And I think the number of these startups is going to explode. There's going to be so many new startups exploring these ideas because, again, just like the leverage of one person is going to be insane. Like at this talk at Y Combinator, there's a bunch of companies working on a bunch of different stuff. There's one startup working on like material discovery. So they were, they had this deck and they were talking about how, there was the Iron Age, and then, there was like the Stone Age, and there was like the Iron Age, and now we're in the Silicon Age. And if we can discover the new material, then this is how we get into the next stage. And this is something where, as a tiny startup, there is just no way you would have been able to fund this, years ago. But now they're just using Claude to kind of discover this and kind of like scan over all the possible molecules and kind of ways to design these materials. And a team of just a few people can maybe make this kind of breakthrough where, 20 years ago, no way.
Right. So the companies may be smaller, but maybe some of the ideas are going to get better, and we're just going to see rapid growth among these small startups that have some kind of insight.
That's my bet. It's like someone that knows the domain really well and has an army of Claudes can just do so much more than what they could have done before, even if they had like an army of humans doing this.
If you have sort of sold one message consistently on this podcast, Boris, it has been buy as much Claude as possible at all times for all things. That's sort of what I'm getting coming across. But it makes sense for the creator of Claude Code. Final question for you.
We're just like so. This is like hard to explain. You know, like I work at Anthropic, so like you know I have to kind of like sell Claude. Yeah. But I think actually in a lot of ways, like we just use Claude for everything. And there is this divide between kind of the way that we use it and I think the way that everyone else does. And so this is also kind of part of the job is, you know, to be like, actually, like you put Claude at the center and it can do totally new things that you didn't expect.
I mean, it speaks to what you said earlier, which is that if you want like AI to make you or your company more productive, you probably need to redesign your workflow around it and not just try to staple it onto some existing process. But you know, and I think that there's evidence to that is true. Right. Last question for you. In addition to everything that you are doing with Claude Code and Cowork, you are also amazingly omnipresent on X and Threads. I see you every day troubleshooting users' problems, offering tips on how to use Claude. If you could automate that part of your job, would you? And how close are we to that world?
I have automated it, but I prefer to do it myself.
Okay. Okay.
I actually, the way that I did it is I have like a loop set up in Claude Code, and now I've actually moved it to a routine. And it just runs every 30 minutes, and Threads has an API, you know, X has an API. And so it just, you know, uses it, and it's really easy to aggregate the feedback and look at it. But actually, my favorite part of my job is just interacting with people, even if they're saying something is broken or something doesn't work or it could be like 10 times better. That's still my favorite thing because that lets us make the product better. And there's this thing in product where sometimes people look back and they're like, wow, this was like a moment of genius, or, you know, like this product was, you know, like someone conceived of it and just like built it and it was like perfect. And that's just like never the way it ever works. Mm-hmm. And, you know, like Claude Code has so many flaws. It's so far from like being the product that it could be. And the only way to make it better is to listen to people, especially when they say something doesn't work, and to like keep improving it and keep making it better. And this is actually the way that awesome product is built. And this is the only reason that Claude Code, you know, it's still so far from amazing, but it improves a little bit every day. And that's the reason.
I mean, it strikes me that's also a really like human part of your job, right? Like when you're talking to somebody who is using a product that you made, it's probably reminding you why you started doing it in the first place, right? And I feel like those moments of connection are like feel really important at a time when we're not always sure what our value is going to be that we're bringing to like an AI-enabled workplace.
Yeah, that's right. And yeah, like we're all trying to figure this out together. This is sort of the thing. Like we have some hypotheses about where this is going. There's a bunch of stuff that we're building because, you know, we think we know where it's going. But, you know, I'm actually often wrong. Like not all of my guesses are right. Often good ideas come from, you know, all sorts of people. And, you know, you never know.
Hey, everyone. Thank you for being here, Andrew. It's great to have you back for year 2.
It's good to be back. This has always been such a cool gathering that you put together.
I was telling you this earlier, but Andrew's fireside chat last year was the most liked and the most watched on YouTube afterwards. So we're thrilled to have him back for year 2. Yeah. Maybe jumping off of that, in the year since we've been here, I feel like there's been a ton that's happened in the AI space. What has happened faster than you would have expected, and what's been slower?
So I think the hype has exceeded my expectations. And then also the doomsaying narratives also got more traction, unfortunately, than I would have guessed, including the job-apocalypse, which I don't think is going to be a thing. And on the more positive side, coding agents probably took off faster than I would have guessed. And the frontier coding agents, I know the hype is that everything AI changes every 3 months or whatever, and that hype isn't entirely true. But that does feel true for coding agents, where it feels like the frontier of what we can do with coding agents, and it's so competitive, right? I think 6 months ago, I was almost all Claude Code. These days, I'm still a lot of Claude Code, but also increasingly OpenAI Codex, with a mix of Gemini CLI and want to support open code as well, because it's open code. So the mix of coding agents we use has been changing rapidly. I wouldn't have guessed a year ago that I'd be coding so much on my phone as well, right? So these workflows, and like many of you, I have a Mac Mini in my computer in my office. So all these workflows changing really rapidly. And then agentic workflows are really starting to make their way into enterprises. That feels pretty good as well.
So on that note, on the software engineering note, what does the future of software engineering look like in your minds?
So about a year ago, I was writing about the product management bottleneck, which is this observation that if building becomes much faster, then deciding what to build, or the product management work of scoping the project, maybe getting customer feedback, deciding what to build becomes the bottleneck. It feels like over the last year, the product management bottleneck has become much worse, in a good way, because software building has become much faster. But it turns out when writing software becomes 10 or 100 times faster, not only is there a product management bottleneck, pretty much everything else becomes a bottleneck. So some of my teams have seen the marketing bottleneck because we can build so many features. Our marketers are scrambling to figure out what on earth the engineers did in order to figure out how to communicate it. Previously, if you had a product that needed legal compliance, if you took 3 months to build it, waiting a week for legal to sign off is maybe okay. But now, if you build it in a day, then wait a week for legal to sign off, that's a legal compliance bottleneck. And there's a design bottleneck and so on. So I've been thinking a lot about how software engineering teams in the future will be organized. And I don't think I know the answer. But increasingly, I find myself setting up very small pods, anywhere from 1 to 10 engineers in a team, of often generalists, high context, highly empowered generalists, that are given a set of very wide guardrails within which they can just run like crazy and build and ship code and even drive decisions like writing marketing copy, that are traditionally outside the purview of engineering. Maybe by definition, let's say you have a team that needs software engineering, product management, a little bit of, you need terms of service, you need some marketing copy, you need some design. Say you need 5 functions represented in a team of 2 humans, then by definition, or by the pigeonhole principle, right, these 2 humans have to play more than a single role per human. But the good news is, it turns out, I don't think I'm a very good marketer, but when I use, AI, right, I'm still not a good marketer, but I'm slightly less bad compared to if I had to do without AI assistance. So I find these small teams of high context generalists that are deeply technical, but able to use front-end technology to do a little bit of other roles as well. Like everyone had engineers, frankly, use AI to take the first draft of a terms of service, to then take to a lawyer, for the lawyer to finally polish it before it goes out. But I find that these processes allow teams to move much faster. So that's been really exciting.
And what's the right background for these folks? Are these engineers by background? Are they coming in from different disciplines and learning to code for the first time? What are you seeing here?
Yeah, so a lot of the people I work with most closely have deep engineering and technical expertise, and then also are highly empowered, slight generalists that step into other roles and acquire this mix of skills, often with AI supporting where they didn't have that training. I think people can succeed from any direction. I've seen product managers become much stronger at coding and then participate in these teams. I think just because so much of AI coding and engineers maybe had a natural advantage understanding the frontier tech. So I see engineers play this role successfully the most often, but there's definitely a smaller number of product managers. I've seen marketers learn to code in pretty effective ways. I've seen operations people start to build more and more products. I think it's actually possible for people of any background to learn to do a lot of this, but the largest number of bodies doing this well right now seems to be people that came from an engineering background, but really encourage everyone from whatever background to see if you can play these roles.
What advice would you have for folks who are trying to get more into this new software engineering space, whether it's particular tools to try or mindsets to have or skills to pick up?
Yeah, so there's one way I've been thinking about the future of software engineering. This is a mental model I have in my head, which is that because of a lot of providers of many tools like RAG, agentic frameworks, things like evals, guardrails. It turns out that so these are AI building blocks. there are also non-AI building blocks, things like user interface components or identity auth mechanisms and front-end, back-end persistence databases and so on. So I think that in computer science, we've always had a wonderful set of building blocks. And with agentic coding, building blocks are proliferating because more and more people are building open source or proprietary API-based or whatever types of building blocks. So they're just wonderful building blocks all around us. And so I find that developers that have a good mastery of enough building blocks can often put them together in combinatorially many ways to very rapidly build software. Right? Maybe if you picture a building with Lego bricks, if all I have is like a white colored Lego brick, I can build some stuff that's not that interesting. But I mix in a black Lego brick, a yellow one, and a brown one, and a green one, and throw in some squiggly pieces of Lego, then what I can build grows combinatorially or grows exponentially as a function of the number of Lego bricks I have. And I think of a lot of the building blocks we now have access to as being akin to that too. So I find that the developers are able to have a good sense of what these building blocks do. And Deep Learning AI offers a lot of long-form, short courses to help people master these wonderful building blocks provided by tons of people. And then the other challenge is to use coding agents to rapidly assemble these building blocks into the software that you want. One challenge that coding agents have is a lot of building blocks are so new that the coding agents do not know how to use them, right? I think until recently, the leading coding agents where, Nano Banana was released after the knowledge cutoff date of a lot of leading models. So they just had no idea how to call the Nano Banana API, or even knew that Nano Banana existed. So one project that one of my friends, Rohit Prasad, and I have been passionate about is a Context Hub, which is kind of a Stack Overflow for AI agents to get the latest documentation on what are the latest APIs, SDKs, building blocks they can use, as well as a way for agents to give feedback to the documentation to try to improve it for everyone. And so it turns out there are a number of APIs that I personally use that, I find the syntax slightly annoying to remember, but I find that by using Context Hub to load the latest docs, I let the coding agent accurately make all of these API calls for me, right? And so it actually has helped my own coding work, accelerate quite a bit.
Maybe two notes there. We also launched something called Context Hub. So we're colliding on names, but it's a very different type of Context Hub. And so, his is much more useful for working with coding agents. So you should go use that. And then deep learning. So I think we at LangChain were the second people behind OpenAI, I want to say, to do the deep learning class. And I know I've talked to so many people who have heard of LangChain through deep learning, and I'm sure a lot of the audience members here as well. So if you haven't tried out deep learning, you should absolutely go take some courses. Maybe on that note, how do you think about education changing in this new world of AI, and have you started to bake any of those practices into how the deep learning courses are run, or how you think about that?
Yeah, so we're trying a lot of ways to improve the education experience. So maybe in terms of training, the thing that's clear is that what people have to learn has changed significantly. I think for developers, to learn coding agents, learn these building blocks, maybe learn some product management or these type of general skills to make us more effective. So what we learn is changing. And Deep Learning AI, Coursera, Udemy try to provide a lot of that training. But separately from what to learn, there's the delivery of training. And it feels like we've been, thinking about how will learning transform for a long time, and it feels like it's actually not quite here yet. One thing we launched just several weeks ago is a new website in preview called codedream.ai, in which the vision was rather than taking an online course, come and have a conversation. So it's not a course, it's a conversation where the experience we tried to build was for you to come and get on a simulated video call with me, say, where if you feel like leaning back and listening to me talk and present to you in a one-on-one simulated video call about Context Hub and coding agents, lean back and I just show you some ideas. Or if you want to interrupt me or interrupt my AI and ask a question, you could do so at any time. And one thing I actually personally playing around a lot with is replacing videos and slides with JavaScript. And what that means is instead of a video, when I present, when I demo something in a video, if you could, click into the video and type your own prompts or type your own queries into the video window. So instead of a static video that just plays, the video area is interactive and just creates more ways for people to interact. So check out codedream.ai if you want and have a kind of a conversation with me or with my AI where I'll present to you in AI form how to use context hub in these coding agents. But I think we're actually frankly still iterating and improving these experiences every day.
Is that clicking into the video and typing, is that live today or is that more of a future direction we want to go?
That's live. So imagine if instead of me screen sharing in a video, I am, JavaScript sharing in a video. And so you can interact with whatever I'm quote screen sharing with because it's running JavaScript code, not a canned video. So yeah, we're still actually. If you favor, we'd love your feedback. But it feels like I think the transformation of education has been overhyped. I think something is coming, but today, taking online courses, I wish we had something way better than online courses. And I would say we have something better than the courses we had 10 years ago. They're much more interactive. It turns out for a lot of our courses, this morning, we actually this week, we just launched a new course on transformers taught by AMD's Sharon Zhou. And I find that rather than just having videos, which is mostly what we had a decade ago, we now build much more interactive visualizations. There's a lot more fun stuff to play with than courses had a decade ago. But that bigger transformation, I actually spent a lot of time thinking about that.
Maybe going from software engineering to everywhere else. How do you see enterprises adopting AI, and what is it faster than you expected, slower? What's the right way to do it? What lessons can people learn?
Yeah, so I think every enterprise, I'm guessing all of yours, are excited about AI adoption. One thing we've seen is over the many businesses, it turns out one of my teams, AI Aspire, which is an AI advisory firm that my business partner, Kirsty Tan, and I co-founded. We talk to large businesses all the time. So the largest kind of Fortune 50, Fortune 500, G2000 businesses about the AI strategies and transformation. So some consistent themes, right? All of us have invested in the bottom-up innovation, let 1,000 flowers bloom strategy. And for the most part, it's not paying off. So CEOs and boards are asking, where is the ROI for AI? I think we should keep on investing in bottom-up innovation. Let's keep on doing that. But it turns out that bottom-up innovation often results in point solutions that drive incremental efficiency gains, which are actually a good thing, but not the transformation, not the broader transformation that AI has been promising us and that I think we should work to deliver. So just to illustrate this with an example, my team's working with a number of banks. We actually do a lot of work in financial services, but work with a number of banks. And if you think about the process of underwriting a loan, there may be 5 steps. You got to market a loan product, get the application, review and approve the loan, do the final diligence, and execute the loan, right? So there's the 5 steps of that. Number of teams have noticed that the step in the middle of loan approval, we could use AI to do that. And if we can automate that, then instead of a human spending an hour reviewing the loan application, we could have AI do it with, and that's great. We should absolutely do that. But it turns out that if your entire process for underwriting the loan stays the same, except for automating what was previously 1 hour of human time, that's a small incremental efficiency gain. So what a number of banks have said is, you know what, instead of doing this efficiency gain, which is worthwhile, let's rethink the entire workflow and market a get approved in 10-minute loan product. Because rather than waiting around for a week for a human to be free for an hour, we can send the loan application to AI right away for a decision. But the challenge with implementing this in a lot of businesses is this takes someone with a broader scope to rethink and redesign the entire workflow, because now you have to market a get approved in 10 minutes product. You have to route the application to approval, not in a day, but right away. So marketing, data infra needs to be involved. Then yes, AI can make the initial decision, and then final diligence execution probably needs to scale up as well. And so I find that bottom innovation is really valuable. It generates lots of ideas, but often it takes, and that has to be complemented with a top-down motion of having someone with a broader scope to change how all of these steps operate to then create growth. And I find that many businesses talk about cost savings. That's fine, worth doing, but I try to push for more imaginative things we could do with AI, which is drive growth, because we can only save so much money, but growth has almost no practical ceiling. So the more exciting ideas I find usually relate to driving business growth rather than savings.
Are there any good examples of driving that business growth that you've seen that you're particularly excited about or think other people should look at and learn from?
Yeah, so let's see. The bank example is a real one, right? We're working with a number of banks on that and financial institutions on that, and other businesses have also done that. I don't know. I find that, let's see, maybe one other pattern. Customer service, contact centers, often viewed as a cost savings thing, and that's fine. Cost savings are nice, but when you can automate customer service or automate or augment part of it, then the ability to serve customers many more much faster, that delivers a more delightful customer experience and drive growth. I think that actually speaking with a number of businesses that have been working on automating the drive-through voice drive-through order process, I think that also results in a more delightful customer experience and drive growth. So I'm seeing that there are more and more of these examples popping up in different places in the economy. There's some I know about that I don't have permission to talk about, but I'm actually pretty confident with the number of things businesses are working on that there'll be more and more examples of these things.
You mentioned ROI earlier, and from a lot of conversations that I've been having yesterday and today, I know a lot of people are thinking about that and thinking about how to measure that. And I don't actually know if in some scenarios, maybe in the cost or in the call center, it's maybe easy to think about measuring that. But how would you advise people to think about measuring ROI, and any advice for them there?
Yeah, I wish I knew. I find that I think part of the challenge is businesses are so diverse. So measuring ROI is like measuring business, which is very hard for a one-size-fits-all answer for. But there's one thing. I feel like the projects that excite me most are measurable, should be measured, deserve measurement. But there are some things where we swing for the fences and create so much value. We're not debating that this drive 2% growth and then minus the 1% cost of implementation. It's just glaringly obvious this is transforming the business. And of course, we still need to measure it, especially when a publicly traded company, blah, blah, blah. But I find that those things to really, there's actually one thing I've learned, sometimes driving incremental gains is harder than driving transformative gains. Because if you tell someone to improve their business results by 2% next year, then it's like, all right, my boss is telling me to work 2% harder or 5% harder or whatever. But if you try to search for ways to drive 20% business growth or 50% business growth, then you can't just get everyone to work 50% harder in the company, and you have to come up with more creative solutions, and that often leads to. Just one lesson I've learned at AI Aspire. We've had many businesses literally send us spreadsheets with hundreds of ideas. I'm still thinking, one financial institution sent us a spreadsheet with over 300 ideas, and asked us to help them sort out of these 300 ideas, which ones to put raw capital to invest behind. And it turns out that the analysis is really difficult. I wish I was smart enough to glance through it and say, this idea and this idea. But I find that when faced with that many ideas, often brainstorm in a top-down and bottom-up motion, is actually a lot of work to do the technical analysis to figure out what is possible, and then also the business analysis to figure out which ones could drive meaningful change. And then it's actually a lot of work on the technical and the business analysis to then narrow down to what's a small handful of bets to put very meaningful resources behind.
And these swing for the fences type things, you're often seeing these being the top-down ones. That's correct.
Yeah, I find that, and I find that businesses hopefully not take one wild swing for the fences. It's more a portfolio of a handful of thoughtful bets where if any one pays off, it will be meaningful for the business. But it turns out one of the things I love about agentic coding is we run tons of experiments, right? Prototype all the time. So the cost of prototyping is plummeted. But sadly, you can't do everything right on a $100,000 budget, and at some point, putting meaningful resources behind every one of a small portfolio of a handful of projects does make sense. But so because of the resource allocation needed at that level, it often takes, a little bit more of a top-down motion to allocate the amount of resources needed.
One of the things that I feel like has been talked a lot recently about enterprise adoption of AI is forward deployed engineers. Will every company have forward deployed engineers? How do you see, why do you think they're so impactful, and how do you see this playing out in the future?
So I think the Silicon Valley buzz, things definitely having a moment of FDEs. I think, and I know Aaron was on stage. She wrote a very thoughtful tweet about it, like 1 or 2 days ago as well. So I think FDEs are a great idea, and many businesses. But I think looking into the future, what do you think is the ratio of FDEs in the company versus the number of just AI engineers employed by the company, right? I think that most businesses will have a lot more in-house engineers and a smaller, team of FDEs maybe embedded. So that's why I like FDEs. I'm excited about the growth. Let's help more people get jobs as FDEs. But I think the hype is also, as is often the case, a bit greater than the actual reality. But it is a good thing. But building agentic workflows is, it is hard. It requires understanding the business. It requires customer-facing skills. Often to make it reliable, you have to drive observability, evals, work with the customer to push back if something is not actually technically feasible, work with the stakeholders to figure out what workflow to automate, help with the change management. So this is a very valuable role that takes deep technical judgment, and having FDEs embedded can really accelerate projects. There's one other thing I see as challenging for a lot of businesses, which is there any way to get a vendor-neutral FDE, right? That turns out to be challenging, and depending on what vendors you want to be really embedded with, because what we see in AI is that the leading AI model rapidly changes. So I have no idea what will be the leading AI model a year from now. I'm actually not at all sure what will be the leading coding agent a year from now. And so in moments of uncertainty like this, optionality is very valuable. So candidly, many vendors are coming to all of our businesses and offering 20, 30% discounts for signing a 3-year contract, right? Whatever. Not giving anyone advice, just saying what I do. I personally almost never sign longer than a 1-year contract, regardless of the discounts offered, because I value that optionality to work with whatever vendor will be the best in a year's time that I don't know about. And then when we work with FDEs, one question that I think businesses are asking is, when you have a handful of FDEs from one company in your company, how much does letting them embed everything with one, AI model or whatever reduce your optionality 1 or 2 years from now? So I think these are some of the businesses that companies are wrestling with. But this is why. But I think I personally have used Langsmith a bunch of times. I think Harrison did a great job making it so easy to use. I think those types of more vendor-neutral tools are very valuable for kind of observing, maintaining optionality for the long term. And the vendors are great. Work with the vendors, but preserving optionality for yourself for the long term also seems important.
On the topic of kind of like vendor neutral, especially in the model space, one of the things we've talked about a little bit throughout the past few days is kind of like open source models. How do you see those progressing, and how do you see them relative to the frontier models?
Yeah, it's been fascinating how it's remained persistently. I'm going to say like maybe 6 to 9 months behind the frontier models. But the frontier models are expensive enough that for many use cases, my teams use a lot of the open weight models, sometimes fine-tuned, sometimes without fine-tuning. So I hope we can all keep on supporting the open weight model. Over the last 2 weeks, there have been concerning noises out of the White House about inspecting models before they're released. So I'm actually quite concerned about that. I'm in touch with a few friends in the administration about this. And I feel like there are a lot of war on open source, open weight models is still being waged, sometimes in the name of US, China, or sometimes in the name of whatever arguments people are coming up with. But I feel like if we can all protect open source, open weight, it will make the world much richer, and also help all of us preserve optionality.
One thing I've discussed with a few folks is basically the importance of getting the data strategy right before kind of like building agents around them. And so as you work with companies who are building agents and presumably want those agents to connect to data in some form, what have you seen work well there? What does those requirements boil down to?
Yeah, this is a great question. So when at AI Spy, when you speak of large businesses, one very common pain point is rethinking the data architecture. Because over the last 10, 20 years, we've put so much effort into organizing our structured data, the tables, relational data, the spreadsheets, and that's great, that's clearly important. But now that AI can process unstructured data, so text, images, PDF files, audio, maybe video, organizing that to get it to AI or agents in the right time, in the right place, for it to create value is suddenly much more valuable than it used to before. And candidly, I've done a lot of work looking at the market. There are many vendors starting to talk about dealing with unstructured data, but I've not been able to find a single good solution that I'm actually particularly satisfied with. So within my teams, AI Fund, AI Aspire, we've been running a bunch of crazy experiments in building re-architects of our own data. If it ever works, I'll probably talk more about it. But I actually spend a lot of time thinking about how to re-architect our own internal unstructured data to get it to the agents for the agents to use at the right time. I actually foresee that just as many businesses had very large data architecture problems, a data architecture kind of a work to reorganize the structured data, over the next few years, there will be very large, I'm going to say tens of millions, maybe hundreds of millions of dollars types of projects in many businesses to rethink their data architecture to make the data more AI ready or more agent ready.
What's the issue with their existing data architecture that doesn't make it AI ready or agent ready?
Boy, I know. Fragmentation, governance, data's all over the place, no consistent schema, some of this sitting on someone's laptop. The permissions were designed for humans, not for agents, so did the agent inherit my permissions? How do we manage governance and observability? I feel like, we've all seen, right? Like so many businesses have massive, buckets of tons of PDF files that no one's looked at for the last 20 years. You see in financial services, a lot of documents are retained for compliance reasons. So previously, there was no point looking at it because no one had the time, but sorting that out for AI to look at turns out to be really valuable. Oh, by the way, one small thing. This doesn't actually the whole data architecture thing, but I think CJ is speaking links.
Yeah.
I was going to say, one little lesson I've learned for AI coding, hopefully CJ will be happy I'm saying this. I personally use MongoDB a lot, because CJ's MongoDB, because we all love relational databases, right? But I find that when I'm iterating and prototyping rapidly, the need to redesign the database schema is so annoying. And we've all had that, 1 in 100 times that we ask AI to do a database migration and did something clever like erase my whole database instead, right? Almost never happens. But the fact that it almost never happens but never happens is, a little bit annoying. So I find that having a NoSQL where I can dump whatever data I want into a database and then figure out the scheme when I'm reading it rather than when I'm writing the database, it lets me iterate much faster. NoSQL doesn't always scale to the largest production workloads. So the very large production workloads, enterprise grade, eventually, I use more relational databases, very scalable solutions. But I think NoSQL is more scalable than most people realize these days, and it drives that pace of iteration. Maybe I just get so frustrated if I've designed, some database schema. I go, oh shoot, I want to add a field. It's just so annoying to have to refactor the entire database. So I find that these are examples of the workflow that we're all making to drive faster iteration, to take advantage of the fact that AI agents can code really fast. So let's not get slowed down by these other things either.
Yeah, it's interesting how coding agents change not only our what we do, but also the technology choices that are good for what to build on top of. I think I speak for everyone when I say thank you so much for being here. Thank you for sharing all your thoughts, and thank you for all you do for the ecosystem.
Thank you. Thank you, Alex.
Hello, AI Native DevCon. I'm excited to kind of be in the home stretch here on this first day, which has been jam-packed and super fun. It has been super fun to be here, and I'm kind of excited today to talk to you about harness engineering, which is a thing that is kind of near and dear to my heart, kind of having invented the term here. And to me, the way that we go about working with these agents is something that fundamentally is brand new, and we don't really know all the good parts yet. But hopefully today I can walk you through some of what I believe the good parts of working with these agents are and how to be effective in your own code bases. To give a little bit of context on why you should listen to me about this, back in June of last year, when we had just had the earliest reasoning models around 03 and the very earliest versions of Codex CLI, which is OpenAI's coding agent, I had an insane idea that I would try and get this tool to do my job. And at the time, with less capable models, that wasn't true. I asked the agent to read my alerts channel in Slack and triage a page. It would not do that. And kind of got myself into this operating mode of presenting myself as a tool to the model in order to empower it to solve problems, issues, and write code on my behalf. And ended up in this very quickly accumulating snowball of effective use of this tool by giving it more and more powerful tools and more context around what it means to do the job. And there's a bunch of patterns here that make that effective and stack really well for your teams that I'm going to go through today. I know I'm preaching to the choir here. Everybody's AI native. That's why we're at the con here. But the way we build software has changed pretty significantly in the last 6 months. I would say in December, with the introduction of GPT 5.2, Opus 4.5, we really reached singularity levels of software engineering and code production being something that these tools do insanely well. And this is a level of disruption that I think we have typically only seen once every decade here. The last one that I can think of is probably like the existence of the cloud as a tool to accelerate ourselves. And with that sort of like cadence of disruptive innovation, we have had a lot of time to internalize changes to our workflows and the way we go about building. But here, the technology keeps changing so rapidly with every point release of these models, where I find myself very often having to reevaluate my priors of what even is possible to achieve with these tools. And I think if you're not in the habit of kind of completely retooling your stack and the way you work with every point release of the model, you are in a way missing out on what it is that you can achieve with these tools. The reasons that the way we have built software has changed and continues changing at an increasingly rapid pace is because we have kind of upended some of the core axioms of what it means to build software. Right now, I'm telling you the models are good enough in order to do significant parts of the software engineering lifecycle, not just writing code, but debugging, triaging, responding to customers, planning, scheduling work, all these other bits that are outside of the core, would you say, production function of a software engineer. A lot of the way we have tooled teams and organizations and roadmaps have been built around this idea that the production of code is this very expensive thing that is going to dominate most of our headcount resources and is slow. And in this world where we can give a prompt to a coding agent and get a PR or 6 out of it, that constraint is no longer true. And we kind of have these teams who were doing the bulk of the production for software that need to figure out ways to increase their leverage by delegating increasing parts of that responsibility to these machines. So for all the software engineers and engineering managers and product managers and designers who are trying to incorporate this technology into your work, all of your goals are to be how to unblock your execution team, these coding agents, from being able to make your ideas, your vision, and your products a reality. So, having just told everybody here that the core constraints on software engineering no longer apply, what are those core constraints, right? We have kind of a new set of problems to contend with using agents in order to produce our software. And to me, these three things are the foundational limits that remain in a world where we are, as a team of humans and agents, producing software. Human time is the fundamentally scarce resource that we have. I know I max out probably at 3 concurrent sessions on my laptop. If I want to be more parallel and have higher throughput, I must find ways to remove my own synchronous attention from the process. Human and model attention are these foundational limits, right? In the architecture of these LLMs, attention must sum to 1. Thrashing the agents by having them do more and more work with conflicting and overbearing requirements in the course of a task is something that is always going to degrade performance. Less and less over time, but it is one of those core limits of the models. So we need to retool the way we work in order to be more parallel, fork off a bunch more tasks, be willing to accept smaller or larger or many more PRs in order to let the agents explore what it means to do the job that we need them to do. And finally, you all probably deeply live this, model context window. Things that get bigger over time, still a scarce resource, something we need to protect. I will say, in my own experience with the GPT series of models, auto-compaction is fantastic. I never think about a context window anymore. I can let a task go for 6, 12, 36 hours and still get good results. But the context window being obliterated and rebuilt over the course of these auto-compactions is something you must contend with, and there are ways that we structure the context we give the model or continually resurface context to the model to deal with this constraint that context windows are continually being emptied and filled. Okay, so we've got these agents that we hope can produce more and more of our software, that we can remove humans more and more from the loop in order to produce more code, more features, solve more user needs, address more critical user journeys with higher quality and fidelity. How do we make sure that we as a team with our agents do a good job? And I think a new-ish thing here is we have to actually articulate that. We have to write it down. I know, like, it used to be the case, we'll have people into the office, we'll have meetings through osmosis, like people will understand what it means for us as a team to write high-quality software, to work effectively together. And agents just do not have that capability. They don't have presence in our stand-up. They don't have this durable memory that accumulates context and battle scars over time. So we have to find ways to make all these non-functional requirements of writing good software legible to the agent. And as an LLM, the thing that it craves, the thing that drives it is text. So figuring out ways to take the definition of what it means to do a good job and write it down is a net new function for a software engineering team in 2026. But it's not enough to just write things down. We need to make sure that this text is a thing that the agent will look at, because it doesn't do much to say you will write reliable network code by making sure that retries and timeouts are consistently applied if that text never makes it to the agent. So figuring out ways that not only we can write things down, but also have them pulled into context at the right time in ways that don't thrash the agent and still lead it to be creative and reason, which are the power of these models, is the important thing. So to kind of take a step back and look at some in the small instances of context and what it means to kind of like think systematically and close loops for the models and for your team. If I were onboarding a new engineer to my team and I was reviewing some React code that they had written, and I knew for this particular set of components, we use suspense because that leads to better performance in the front end. I would be able to give that feedback once to the human, and they would incorporate it into their mental model of the code base, what it means for these different screens to relate to each other well, and I would largely solve that problem going forward by empowering my teammate to know more about what it means to do a good job. But I can't really do that with an agent in the same way, so I kind of have to step back, give that review feedback on an agent-produced PR, and then myself figure out a way to make these mistakes statically impossible going forward. And it might be the case that I'm looking at all those review comments, seeing this is missing context that the agent was not able to pull in at the right time to know that the code that it wrote was misaligned. How do I figure out where I can write it down, what lints I can have fail, what tests need to exist, whether or not I can empower a reviewer agent to look at all the proposed diffs through the lens of these guardrails to make it so that this feedback is actually durably encoded as a static guardrail that we apply to every PR going forward. It's not enough to do point-in-time fixes with these models. We want to make every mistake something that is just not possible. I never want to give the same review feedback twice. And this is really the core of what harness engineering is. Harness engineering is making context around what it means to do a good job legible, and then just in time surface to the agent over the course of its trajectories in order to steer and refine its output to make sure that every PR we get adheres to the golden thread of what we consider to be acceptable, high quality, aligned software. It's kind of funny when you work with these agents that what I would normally consider to be like good practice around DevOps and shifting left as far as possible in order to make things cheaper earlier in the process, I don't do that at all when working with agents. In fact, I try and put my interventions as far right in the process as I can in order to minimize my own synchronous time having to engage with these issues. For example, if I'm working on a PR and I realize I get a bad result, it might just be the case that I'll trash it, change my prompt, and probably get something good out of it. But that's not really a durable thing. It's not reliable. I don't socialize those improvements to my team. So sort of the next level of shifting that left is to write it down. And if writing it down is not enough, writing down and then empowering a review agent to judge every diff is another way I can shift that left. And then I can shift it left further into statically verifiable lints and guardrails and tests and on and on and on earlier in the process. And we think about this as needing to surface to the agent all those sets of non-functional requirements. It is not the case that these agents don't know how to write high-quality software. They absolutely do. But as artifacts of their training, they have seen every possible permutation of every possible choice that goes into producing software. And it's up to us to prune latent space to tell it which choices we want to make. If I am using these things to prototype a new data science model in a Jupyter notebook, I have a very different set of choices I make in the production of those diffs than I do if I am working on adding a new index type to a database. They're just fundamentally different tasks. So it's up to us as owners of our code bases to make legible the sets of decisions that we make in order to produce our code, what it means for something to be a prototype versus production feature that requires a staged rollout with A/B tests and feature flags. And if we write this down and give the agent some tools to reason about what type of change is being made, to find runbooks that are appropriate to refining its output over the course of its PRs and epics, we can give it bounds and context, but still give it the space to reason, be creative, and cook. One maybe non-obvious thing is that because the agents crave text, every bit of text that we feed them is, in some sense, prompting. It's going to inform what tokens get predicted, which means it's going to inform the code and the diffs that we produce. This means all the code in the repository of itself outside of the documentation knowledge base is also prompts. So if we think about aligning the code base or unifying it all on the same patterns, we kind of limit the amount of attention the model needs in order to do a good job. If I am able to standardize on OTel across my entire stack, for example, when the model thinks observability, it's able to translate context that it sees in one part of the repository over to something halfway across the code base without any loss of quality or intelligence. But if I have 6 observability stacks in the code base, the model's going to have to spend a lot more time figuring out which one do I use here? Is this migrated or not? What is canonically good? So over the course of the PR, there's sort of 3 phases I think about when we're talking about context delivery. And because we are curating the code base in order to make it efficient to deliver context to these agents, we also want to encode that in the operating loop we give the model. To me, the most important thing that ends up in that agents.md file is a numbered set of steps that we expect the model to go through over every rollout that we do, over every session. We first want it to ground itself in the documentation knowledge base, in the ticket that is proposed. We want it to spider through our history of ADRs and design docs to figure out how this might impact other features of our code base. We want it to look at the critical user journeys to inform itself around what screens and user surfaces are impacted so it can keep the QA plan in mind over the course of its execution. We expect some amount of slowness during this process because we want to page in all the context around what it means for this feature to slot in globally. Then there's sort of the messy middle part of the run where the agent is writing code, running tests, exploring the code base. And for that, we exploit the fact that these agents are going to call a bunch of tools, run a bunch of tests in order to use them to just-in-time prompt inject the agent to steer its output back to baseline. The tests we write, the lints we write for agents are very different than the ones that we write for humans. They by default recognize that agents are going to truncate tool call outputs, that they respond really well to descriptive error messages that point them to runbooks for remediation steps. And we are willing to have very many of these things that are kind of fiddly to write and I wouldn't normally think about. To go back to this sort of network code example, I am sure all of you have been paged at some point in your careers around an outage that boiled down to a missing timeout and a retry on a cross-service network call. And the collective amount of engineering time that has been spent on this very common failure mode is astounding. But still today, like there's no code that asserts that we pass retries around. There's no like ESLint plugin that I can slot into my code base that's going to do this for me. But because the production of code is very, very cheap now, we can absolutely vibe a set of guardrails into place with 100% code coverage and exhaustive table-driven tests, and migrate the code base all in one go, and just-in-time surface this failure to the model every time it writes another fetch call, and never have to worry about this again. And because we don't have to pollute context window up front, and we can exploit the fact that a tool call output is going to be given less weight during an auto-compaction, we just-in-time correct the model, and still let it go off and do the complex work that we wanted to in our original prompt. And then, sort of after the run, we have a much easier task of determining whether or not the code, the diff, the artifact is aligned. Because it's a static thing, and we have static sets of guardrails, and can use very, very many LLM as judge to look at the code, operationalize it with a set or three of static guardrails. This is what it means to write reliable code. This is what it means to write performant React. And make a determination. Is this good or bad? And if it's bad, why is it bad? Because the LLMs crave text, these LLM as judges can collaborate with the implementation agent over that PR thread, give more text back to the implementation agent, and further realign the proposed diff back to baseline. So we've got agents.md kind of as this map that shows where the context is, during what types of work the model might want to look at that text, but otherwise not being prescriptive around any of the guardrails. We don't want to jam a ton of rules in here because we're going to chop up latent space too much. We're going to make it difficult for the model to spider through the code base with creativity. I find it very, very useful from this agents.md to point to a curated set of review personas that are essentially bulleted lists of guardrails. And I find this really, really neat for an interfacing with the other humans on the team perspective, because it is so cheap as a team to have a Slack conversation in a thread around what it means to fix that performance regression, and then mention the agent in it to say, yoink all of this and put up a PR that adds it to our static set of guardrails. It's so cheap in order to continually refine and improve the output of our agents in that way. I also think it's really neat to take that same sort of pattern and apply it toward documenting what your product features are. or what the critical user journeys are, or why your apps even exist, what user problems they solve. All this context that we can give the agent helps ground it in what we are trying to do and why, how our team thinks about working, because all of this is going to produce more and more aligned output. In that messy middle, we can kind of use tests on the AST, tests on the structure of the files on disk, really blunt hammers around file line counts, or whether or not snapshot tests exist. These very, very coarse-grained tools in order to make the model do what we know is good. Just requiring that every React component in our code base has a snapshot test that gives 100% branch coverage means that the model is naturally decomposing these things and making them pure where possible, and not doing prop drilling and putting hooks close to where the data is used, because that makes it easier for it to fill the requirement that there must be snapshot tests. And we can do this, we can assert this, because it's free to produce the code that spiders through disk and matches up the snapshot test to the underlying component. Another failure mode that I hear folks talk about a bunch is that, these agents are doing type shape probing all the time. I end up with these any's or unknowns all over the code base. And the way I've approached it is to just statically disallow any function that has a type of any or unknown, unless it's parsing input in a route handler or from the database. Other than that, with ESLint, we just ban the existence of that type. We require the code base to be 100% typed, which means all this bad behavior and weird type probing just kind of falls out because we require 100% code coverage. These functions cannot possibly be exercised because the unknown types can't exist, and we get more aligned code. More aligned code that I would consider acceptable, high quality, maintainable, and all these other sorts of properties. And having these failing checks tell the agent why they failed and what to do instead means that it's able to self-heal. Ultimately, as we move into that third phase of review and merge, we want to treat the model as if it's another member of the team, and it needs to convince me to merge its code. I'm not shoulder surfing any of my teammates in VS Code or Vim, right? When they put up a PR and they attest that they tested the code, I take their word. And if I am unsure, I'll ask them to show me the logs from the staging deploy, or to post a screenshot of them exercising the feature in the app. And we can require these agents to do the same thing. This is a lot easier these days now that we have things like computer use and browser use. The Codex app is fantastic, highly recommend it. But even without that, vibing yourself up an Xcorks connected headless display in a Docker container and wiring up FFmpeg to that stream to record a reproduction video is within reach, because I don't care about how gross this code is, and Codex is able to sling FFmpeg better than anybody in this room, probably. On the back half of things, where we are looking for ways to accept the diff, I'm treating it again like I would my human teammates. Benefit of the doubt, bias toward merge. What are the P2 and above things that would be necessary for me to accept this code? Use the reviewer agents, which is really just a matrix CI job that points at a bunch of markdown files, to judge this thing, drive these remediations to completion, get the coding agent to pick them up, implement it, get the reviewers to be happy, and off we go. And this sort of process, with me observing along the way of which review feedback is regularly getting surfaced, why is it making it to this part of the pipeline? Maybe I need to use that as a signal that I need to shift some of these guardrails left, and then I can spend my time, and the reviewer agents can then spend their time on more bespoke or more complex changes that we need them to look at. Another thing that you should be thinking about doing as a team is how to systematize capturing all of this human feedback. Every review comment, every time you have had to interrupt the agent, every agentic intervention, every failed build, every exception in production, all of these in some sense are signals that context was missing to the implementation agent, that it did not consider the full end-to-end consequences of the code that it wrote and whether or not it would be successfully deployed. And what we are trying to do, which I expect you'll learn about in the next talk, is slurp all this data up and dream over it every night, pointing a bunch of sub-agents at it, trying to distill whether or not there's anything that humans can do better in their prompting, whether there's missing guardrails that should exist in the code base that disallow this behavior, and how we can get to a world where we're more and more headless, less human interrupt dependent, and able to trust the agent to do more and more complex things headlessly. I think vibe coding is a big part of what it takes to be successful here, because there's a ton of guardrails that only affect my local development process. This code can be gross, but it brings into possibility this idea that I don't need to care about some parts of the software production function. This lets me operate like a group tech lead or an org lead, where I don't have visibility into every single engineer's activity on the keyboard. But the thing I care about are invariants, interfaces, whether or not the components that they're producing do what they say on the tin with high reliability. And with that, I'll just leave it with y'all can go build things. These tools are fantastic. Go get after it. I'll take some questions now.
Thank you so much. Thank you. Pow, that hand went up really fast. Hold on one sec. Oh, do you want to grab that one?
Hello, great talk. You mentioned earlier in your talk that you find that you don't need to shift left as much as before, you stay more right. And I'm curious about that because isn't it better for agents to see something in a lint rule rather than as review feedback, for example? Like what do you mean by staying more right and not shifting left?
So I think once you kind of put these structures in place to surface these requirements to the models at the right time, it becomes pretty easy to rely on them for the most part to auto-discover this stuff. It is very often the case that our agents.md paints a picture of which guardrail files are relevant for which categories of changes, backend, working on the design system, these sorts of things, where the models will just naturally page those sets of persona-oriented guardrails into context, which means I very often just don't see patterns of misbehavior in that way. Only if, for example, guardrails are commonly required over tasks that span 15 context windows, and by then the context in those guardrail files has been auto-compacted away, then that's the sort of thing that I would use as a signal that, okay, this is the thing that I need to shift left further on. But I do recognize here that it is sort of predicated on making sure that like those auto-discovery functions are things that are reliable.
Probably got time for one more here.
Is there a practical implementation of the harness you've just mentioned in terms of some end-to-end implementation of those capabilities before, during, and after?
I have started to bring some of these techniques to my open source work. I used to, long ago, build a Ruby interpreter in Rust called Artichoke. There's a bunch of crates out of that work that I still actively maintain. Probably the most interesting one for you to take a peek at is randmt, artichoke/randmt. It's a sort of Mersenne twister implementation. Been doing a lot of fun stuff exploiting automations in the Codex app to basically take my hands off the wheel for a ton of the maintenance tasks of this OSS work. I haven't quite gotten to putting those review agents in place yet, but it's coming.
Any final questions? Nope. Okay. Big round of applause for Ryan. Thank you so much.
Thank you, everyone.
I'm here joined with Boris. Before we get started, we need to take a selfie real quick, if you guys can join us. I'm going to take one real quick, all right? All right, here we go. Everyone say cheese. Just kidding. Okay, we have 40 minutes joined by my amazing friend, Boris, who doesn't need any introduction, but in case you haven't heard of him, he's the head of Claude Code. I'm a director of product on the dev infra team here at Meta, supporting our AI developer productivity stuff. And we're going to just have a friendly fireside chat to chat about a bunch of different questions that we have for Boris. There's a QR code, I think that was shared up screen earlier or somewhere. We are going to have a later portion of the talk to be open mic. So I have an iPad here with a bunch of questions that you guys are submitting. We'll go through some of those top voted questions. But as you guys are going to fill those out, I want to quickly ask folks, how many people here use AI to write their code? Just a quick raise of hands. Okay, good amount of people. Keep your hands up though if 100% of your code is written by AI. Let's look around the room. How many people is that? Okay, it's a lot more than before when I asked these questions. So it's really kind of an interesting time to be here talking about this stuff because all of us are witnessing this transformation in our industry. And so I think we're going to get this question started. I'm going to have a few questions that I'm going to start off first. And then as you guys fill this out and vote on the top questions, I'll get to those afterwards. So just a few quick warm-up questions for us. How many lines of code have you written this year?
How many lines of code?
Yeah.
So I pulled the answer for this in prep because I knew you were going to ask that question.
Yeah.
Okay. So 1.7 thousand PRs, added 400,000 lines, deleted 250,000 lines. So
okay.
I think last year it was actually I deleted more than I added. But this year I added a little bit more than I deleted. And I also tried to get the token count. Unfortunately, the data kind of gets deleted due to retention and stuff. But since March, I used 8 billion tokens.
8 billion tokens. And so those lines of code that you deleted and added, those were all written by you or Claude Code?
100% of my code has been written by Claude Code since Opus 4.5. So that's like November of last year.
That's crazy. And then do you use your phone or your laptop? Like what's the split nowadays when you code?
Yeah, this is sort of like the craziest thing. Like I would not have predicted this if you asked me like 6 months ago, where are we going to be doing our coding? But yeah, like most of my coding now is on my phone. I would have said you're crazy if you told me that 6 months ago, but yeah, here we are.
Yeah, it's crazy, right? Okay, I think one of the questions that a lot of people have been pinging me about and we really want to get your thoughts on is really starting to think about like efficiency and ROI. We kind of like hear of Uber and other companies starting to set like monthly budgets, for example, like $1,500 per engineer. But at the same time, Anthropic, you guys and other frontier labs are pushing out these more capable but also more expensive models. What do you think about this? Like, what are your thoughts on how companies should balance this tension between like more performant but costly models versus like having to start to demonstrate more efficiency, token efficiency?
Yeah, totally. So, like luckily I get to talk to so many companies every day, that are, our customers and kind of future customers. And broadly, people think about it in two ways. Some companies think about it in terms of the cost. And other companies think about it in terms of ROI. And I'm like, ROI is absolutely the right framing because you don't want to just think about cost because you kind of spend something on it and you get something back. When you think about ROI and kind of like deploying Claude Code in general, I think it's useful to think about like what's a really good way to deploy it. And I think like the most successful companies we've seen, they sort of give everyone tokens, not just the engineers, but also like the product managers, the designers, the data scientists. They give everyone tokens and let the company experiment to see where the ideas come from. Because often it's just like not the person that you would expect. Often some of the most interesting ideas and the most innovative like ways to improve processes and kind of like new product ideas, it's gonna come from like, like an accountant somewhere in the corner of the org or like a marketing person that you've never heard, that the CEO has never heard of. That's where a lot of the innovation comes from. It won't necessarily be like the most senior engineer always. And so I think for this reason, like you kind of want companies to experiment and you want your team to experiment. The way to do this is give people tokens and give them safety to experiment. So they feel like they can try stuff and they're not going to get kind of penalized for it. Once you find these internal use cases that kind of work, then you want to control the costs. And you want to do that on the back end, not on the front end. And like once there's some use case that takes off, uses a lot of tokens, then you want to think about how to like optimize that. There's all sorts of ways like, like in Claude Code, we have like per seat cost controls. There's ways to use like advisor models. You can change the model for your entire company. You can control the effort level for your entire company. You can set budgets like based on department, based on RBAC. So there's just like all sorts of ways to do this. I think that maybe like the second way to think about it, so this is kind of like the deployment side and like how to actually get it out and like when you're like at the very beginning. Once companies have been using Claude Code for a while, you really do want to think about ROI. And you know, like for ROI, there's kind of like two parts. There's the investment and there's the return. In the past, the way that, you know, investment is easy to measure, that's just tokens. Return in the past, the way that we used to measure it is what percent of the code is written by AI, or maybe like percent increase in the lines of code or something. And yeah, like, you know, we just saw a bunch of hands go up that said, you know, like 100% of your code is AI. So once it gets to 100%, how do you actually like measure that return? And that's where it gets kind of hard because, you know, like we worked on DevInfra back in the day. And, you know, like on DevInfra, you know, like if you have like a percentage, like 2-3% productivity improvement for a year, that used to be like pretty good. Now the productivity improvements we're looking at are, you know, like hundreds of percentage points. And at Anthropic, you know, we've seen like a 8x increase in code per engineer since the beginning of this year. And so like in this kind of regime, how do you think about the return? And so I think part of it is get to 100% of your code written by Claude. Then think about how much is the code per engineer accelerating. And then the third thing to think about is like, what are the other bottlenecks that are getting in the way? Because once you get it to this point where engineers are just like writing a lot of code, the bottleneck is going to be like good ideas. So how do you kind of unhobble that so that your company can generate ideas faster? And this could mean like more PMs or user researchers or something. Then you have to think about how to get these ideas to market faster. So this is kind of unhobbling on the GTM and on the marketing side. So this is kind of roughly the order that I think about it in. And when I look at our customers, everyone is kind of like a different step of this adoption curve.
Yeah, I think it's really interesting to think about, like kind of how you said, it started with coding and just getting more and progressively more hands up, whereas like 100% of their code is AI. But then you start to realize there's upstream and downstream bottlenecks to the ultimate thing that companies want, which is delivering more business value. So like unhobbling those ideas, getting code to be deployed faster and safely and more accurate. I think those are all the things that the whole industry is like figuring out. It's like, okay, let's say coding is like more or less largely getting solved with AI. What are the things now that's blocking coordination and collaboration? I actually see one of the top voted questions is about that. So we'll talk about that in a moment. But I think that's like the interesting question we're in now. It's like a year ago, if we were doing this fireside chat, we'd be talking about like, how can we use AI more for coding? How can we sort of like do all that? But now it's kind of like the next question. It's like, okay, what's next now that coding is more or less going to be more and more just written by AI? So I think that's a really interesting situation that we're in right now. All right, next question I have. So for context, Boris and I actually used to work together on Threads. So of course, and also Threads just hit 500 million monthly actives yesterday, we announced.
Congratulations.
Thank you. So I had to obviously ask some folks on Threads for some questions. I have one question from there I want to pull out. It's actually from our ex-colleague, old colleague, Peter. He asked, like, is loops the next hype cycle or is it real? Maybe you can explain what loops are for maybe people who aren't familiar with it and then how you use it personally.
Yeah. Have people here tried loops, routines?
Still pretty nascent, yeah.
Okay, and just so I know like how technical to make the explanation, raise your hand if you're like an engineer that codes. Okay, so I think like for the engineers in the room, the way to think about it is 2 years ago, we wrote source code by hand. We started to transition to make it so agents write the code. And now we're transitioning to the point where agents are prompting agents that then write the code. Or maybe that's like the less technical explanation. The more technical explanation, like actually my mental model is sort of like if like source code is like kind of like the basic level, that's sort of like a statement in programming, then the agent writing the code is like a function in programming, and then loops are like a higher order function. So it's sort of like we're stepping up the abstraction ladder. It's one more step.
Yeah.
So loops are sort of like as big as the step from source code to agents was, loops are the step from agents to the next thing. It's just as important and as big a step. To me, it feels like right now in the world of like loops where, I don't know, like maybe where agents were like a year and a half ago. So it's still like fairly early, but we're starting to see signs that it's working. And the idea is like, okay, let's say as an engineer, a lot of my work is to do code review. And so like one thing that I could do is like, I could do the code review by hand. The other thing that I could do is I can have an agent and I can prompt my agent to do the code review. The loop version of this is I have an agent that's running in a loop that does all of the code reviews. Or like another example is, like I read threads to see like people's feedback. And so like I could do this by hand, or I can have an agent do it, or I can have an agent that's constantly looping over and every like 5 or 10 minutes reading the feedback and putting up PRs for the fixes. And so like like a year and a half ago, we were kind of at the first step, now we're kind of at the third step. And so like when you think about all the work that we do as engineers and all the work that, like non-engineers do, like designers and data scientists and, like marketing people and so on, a lot of the work, I think we can probably chunk up into loops in this way. And I think we're starting to get to the point in the industry where like a bigger and bigger percentage of the code is like expressed as loops and a bigger percentage of the work. And so for me personally, maybe at this point, like 30% of my code is written by loops on an average day. If I try really hard, I can get to like 100% for some days, but it doesn't totally click yet.
Nice. I feel like if we ask the question of how many engineers write loops, maybe in a year from now, we'll see more hands. So in some ways, you're always like just kind of living the like 3 months, 6 months ahead of the rest of the team here. And so like I think loops is something that's been fascinating too internally. I think people have been starting to explore what are the various ways you can orchestrate all the various tools you need to kind of create this sort of like automatic loop. Because like right now, humans are in the loop, right? You have to be every single part of the way. We were just talking about in the first question, how to kind of like get this sort of process more and more automated. And so getting this loop going is really sort of like the key to figuring this out and getting more productivity. The other thing we've been talking about for a while is that Anthropic's been investing a lot in co-work as of late. I'm pretty sure a lot of the audience here primarily uses Claude Code. I think it'd be great if you could tell us sort of like why folks here should use co-work. What are some of the use cases you're most excited about? Especially related to the first question we talked about, just like how people are using it beyond just coding.
Yeah, totally. So for folks that don't know, like the way that you try co-work is you download the Claude desktop app. That's the same app that has chat and Claude Code in it. It also has co-work in it. So you just download it, you can use it, works on Mac, works on Windows. Co-work is Claude Code for non-engineers. It's just Claude Code under the hood, and it actually uses the same like Claude agent SDK that Claude Code is built on, so the infra is the same, and you can actually build on the SDK yourself too. It's exactly the same thing. The reason we say it's not for it's for non-engineers is there's a bunch more guardrails built in. So co-work has like an entire virtual machine. It has this like actually quite sophisticated isolation, and we like hook into the operating system to make sure you don't accidentally delete stuff. There's a lot of protection for prompt injection. There's all sorts of things that we do that are, make it a little bit harder to shoot yourself in the foot. When I think about how I use co-work, I actually use it for everything that's like non-engineering. So, like one example is I use it for project management. And so like we used to have stand-up every morning where we talk about here's what everyone on the team did. And now actually what we do is I have co-work and it opens up this like spreadsheet in the browser, and the spreadsheet has essentially like all of the work streams for the week. And it'll message every engineer in Slack for me automatically to ask like, what's the latest status? And often their Claudes will respond.
Claude's agents talking to agents.
It's like the Claude's talking to the Claudes.
Yeah, Claude.
But sometimes like engineers will respond, and then like co-work sees this, and then it'll fill out the status in the spreadsheet. And all this is like co-work will open a browser and it'll do this for you. It's like zero setup. You just need co-work and you need the Claude Chrome extension, and then they'll just kind of work together to do this. So this is like this kind of magic of combining tools. And I think that's like this like magic moment that people see when they use co-work is like, oh my God, this thing can use my tools. And it can combine all my tools for me in the way that I would. And it just feels incredible. It feels like using like a AI chat app for the first time. It's like a revelation. There's this like more sophisticated usage. One thing that I used to do is I would use co-work to book all of my travel. So what I would say is like, okay, here's like my itinerary. I need to be here on this day, here on this day. Can you like go out and book the plane tickets for me? And again, it would like open a browser and it would go to this like, travel site that we used to book stuff at Anthropic. And it would just like fill it out and book the tickets. And what I've done now is I've actually automated it a little bit more. And so what co-work does now is it has a scheduled task where every day it'll look through my email. It'll look for any events that I've accepted on my Google Calendar. If the event is in a different location, then, like it's not in San Francisco, it'll go and it'll automatically book the tickets, and then it'll send it to me. And it'll book like the tickets. It knows to book like hotels, and it knows all my like flight and hotel preferences, and it'll just do this automatically. And so, like I was just in Tokyo for Code with Claude, and then, I was in London and Berlin for Code with Claude before that. And it just fully booked all the tickets for me. It was this like multi-leg like flight and hotel thing, and it just booked everything. I wasn't involved at all.
Intervene at all?
Not at all. Yeah, it just like it found it in my email and it booked it after I confirmed.
It's crazy. Okay. Yeah. I mean, how many people here has tried Cowork? Just curious. It's a good amount actually, right? Hopefully more. That's great. I think another question that I got a lot of pings about, would love to hear your take on this, is that many of us only got access to Fable for like maybe 3 days or so. So while we wait to hear what happens next, obviously I'm assuming you had access to it for much longer. Share maybe some of your experiences with how you use Fable for coding, and now you guys have a family of different models. How do you think about using different models for different software engineering use cases?
Yeah, totally. And like first of all, like with Fable, just want to say, from our point of view, it's a misunderstanding, and we're working to hopefully get it back really soon. The way that I think about Fable is, with coding, there was this moment back in November of last year. I don't know if everyone like remembers this, but everyone started like posting on Twitter and kind of talking about like how good the model has gotten at coding. And what happened is Opus 4.5 came out. And the leap from the previous model to Opus 4.5 was so big that for a lot of people, they just started writing all of their code using Claude for the first time. And that was actually the moment for me where I just uninstalled my IDE because I wasn't using it anymore.
Wow.
And so like for me, that's the same moment when Claude started to write all the code. The leap from Opus 4.8 to Fable feels to me like a leap of at least that same size. And I think it might be even a larger leap in model capability. For me, Fable is it's just like it has this like nuance and dimensionality and kind of like way of thinking about things that is kind of like similar to like my smartest coworkers. It's not just like a blunt instrument the way the previous models were, where it doesn't understand nuance. It's actually like really able to grapple with a problem. And this is useful for all sorts of things, from like data analysis, because there's a lot of nuance there, and you have to understand like, you have to ask why like 3 times to get to the bottom of a question. Fable just naturally does this. It's useful in debugging, where you have to form a hypothesis and you have to kind of like chase down that hypothesis, look for evidence. It's able to do this really well. And for coding, I feel like I actually just ran out of hard problems to give it. Like I just couldn't think of a harder problem. Like every problem that I gave it, it essentially one-shotted, or maybe like few-shotted with a few prompting, with a little bit of prompting. I just kind of ran out of hard problems, and this is something that I heard from a lot of the team also. So yeah, it's like it's quite a big step.
Is Claude Code just basically 100% written by Claude Code at this point?
Yes, that has been the case again since November of last year.
Oh, so it wasn't even like with Fable, it was like with Opus 4.5.
Yeah, with Opus 4.5. Yeah, that's true for Claude Code, that's true for Cowork, it's true for an increasing number of Anthropic's products. I think across all of Anthropic, 80 to 90% of the code is written by Claude Code on average. Mm-hmm. But actually for a larger and larger share of teams, it's just 100%.
I also heard that Fable is like more expensive, but it's also a little slower, but it's also like incredibly intelligent, like you said. How do you just use Fable for like all of your tasks, or do you drop down to like Opus or Sonnet for different kind of use cases?
Yeah, I use Fable for everything.
Just a Fable for everything. Is it because Anthropic has no budget? No.
So, like at Anthropic, we do actually think about token use, right?
Yeah.
Like we essentially make the tokens.
Yeah.
But they're not free for us, because every token we use is a token we do not give to a customer.
Right.
So there's an opportunity cost. When I think about it, it actually maybe comes back to ROI. So like when you think about kind of ROI for something like Fable, you can reduce the investment maybe like 50% or something if you use like, Fable with an advisor model, or, use Opus by default and have it call out to Fable when it needs. So there's like all sorts of ways to optimize usage, and as new models come out, you have to kind of keep tuning the way that you optimize this usage. It's actually quite a bit of work to keep up with it, and to keep that, you have to like run evals to make sure it works pretty well. Although, like you can use advisors. That's kind of the recommended out-of-the-box approach. But I actually think that if you think about ROI, there's probably like 50% chance to reduce the investment, but probably like 1,000% opportunity, or even 100,000 or 10,000, whatever percent opportunity to increase the return. And so what I would think about is just use the most expensive model and focus on how do I get more out of it? How do I increase the return? Do not focus on cost cutting. It's just like, it's so early in kind of like the adoption of this technology to think a lot about this. And you probably want to spend like some effort on cost cutting, and like you definitely want to make sure costs are under control and kind of well governed. But I would focus almost all your effort on increasing returns.
Yeah, focus on the upside more than like the potential downsides, essentially.
Exactly, because there's so much more upside right now than there is kind of like room to optimize the downside.
Yeah. Hopefully, the rest of us get access to fuel soon, so we can kind of all explore that as well. Okay, I think we got a decent amount of questions. Actually, there's 107 questions. We're obviously not going to get through all of them, but I'm going to handpick and kind of like MC some of the top voted questions that we got here. So Andrew, kind of the top voted question here is saying, what is Claude Code doing to improve collaboration? Currently, it feels like a solo work product with only awful things at GitHub for working with others. Wow, that's a interesting question. What do you think?
Yeah, we have a bunch of stuff in the fire that we're cooking up. So hopefully we'll have something there soon. In the meantime, the thing that I would recommend is use an MCP to hook up Claude Code to Slack or to Teams or to GChat or whatever you use for collaboration.
Sounds good. The next voted question was, since agents can do most of the code now, where should engineers focus most? Kind of touched on this earlier, but yeah, curious.
Yeah. So, like as we think about like what engineers do, one of the things that we do is coding, but we do like a lot of stuff that's not coding, right? So we do, like talking to customers, coming up with ideas, jamming on stuff with designers and PMs, doing data analysis, figuring out what to build next, aligning with other parts of the org. There's just like all sorts of things that we do as engineers. I think over time, the model will be able to do all of these things better than we can. We're not there yet. And so I think in the meantime, like the model does the coding, but someone has to prompt the model. And figuring out what prompt to give the model, there's actually like a lot that goes into that, right? Like you have to kind of figure out what's the next thing. You have to do the market research. You have to talk to your team. You have to do all this other work. So yeah, it's kind of all these other things.
Yeah, and I think, like you said, with loops too, that's also progressively moving up the abstraction layer, where maybe at some point, for some certain cases, you don't even actually need a prompt. And so I think it's interesting, like I said earlier in this conference, is like we're in this like transformational stage. We're all figuring this out together as an industry. We also have seen at Meta that like you said, it's actually a minority of an average software engineer's time is actually spent coding. It's all the other things that kind of happen upstream and downstream with it, whether it's I'm here joined with Boris. Before we get started, we need to take a selfie real quick. If you guys can join us. I'm going to take one real quick, all right? All right. So that's really cool. I think it's actually a good segue into the next question that I wanted to ask, which is like, what is the next big thing for you and your team? Like, what is your vision for the next year? I mean, you kind of mentioned like just solving bottlenecks as you come across, but like, what is the vision for Cloud Code over the next year?
Yeah, so, okay, as a caveat, we plan on like a weekly or monthly cycle. We don't have a 1 year plan. The space is changing too fast. Like the exponential is crazy. You have to hang on and plan like a little bit at a time. Broadly, the direction for us is very similar to the direction from before, like from the last year or from the last 2 years. We want to be the most capable agent. We want to work anywhere. So wherever your team works, Claude works. You don't have to like switch to our, full stack to use it. And we want to let people experience the capabilities that the new model brings in a way that other products don't really let you experience. And this is something that we realized a couple of years ago. SOM 3.5 was quite a big leap in coding, but we felt like there weren't really a lot of products that let you fully experience that leap. And so Claude Code was like a way to get at that. It was the idea was like, okay, no more source code. You're just using an agent. That's the way that you experience this. And as we think about the model over the next few months, over the next year, it's going to get even better at long-running work. Like Claude is already by far the best at long-running work. That lead is going to increase, I think. The code is going to become more secure. It's going to become higher quality. And the model is going to become even better aligned. So whatever your intent is as the user of the model, as an engineer or a product manager or a designer that's using the model will be even better at expressing that intent. And so like we're going to be kind of like looking at these capabilities. We're going to be looking at like what are the products that we can build to let people experience this in the easiest way possible.
Nice. Reza asks a question here that I thought was really good too. Coding in large-scale projects is not the biggest problem. Maintenance is. How should the code be maintained in long term? Like, how do you guys deal with maintenance?
Yeah, so it was something that I've been experimenting with is actually using like loops for maintenance.
Loops for maintenance. Can you share more?
Yeah, so one example is you can have Claude Code running in a loop to be like, look at the code base and improve the architecture. Or look at the code base and find places where the test suite is, flaky and improve it. So, to get rid of the flakes. Or find instances of tests that are not useful that we can just like delete. Or, look at the code base, look for duplicated abstractions and unify it into a single abstraction. And so these are actually like all loops that I have running.
In those cases, do you check or review what the code does before they delete or make any changes, or you're just you just send out PRs and you're just like reviewing them after they run the loop?
Yeah, it's the second one. So I just look at the PRs.
You just look at it, the change after they made it.
Exactly. For prompts like this, it's actually like quite easy, I think, for Claude to kind of wrap its head around these shape problems. So it's usually quite good if you use the latest model. And if the result isn't good, all you have to do is say, look for opportunities to improve the quality of the code base, and then just add the magic words, use a workflow.
I thought you were going to say, make no mistakes. I thought that was
maybe that would work too. But yeah, it's like essentially like just say use a workflow and it'll throw more test time compute at it and it'll give you a much better result.
Yeah, that's really cool. Workflows is a pretty new concept. I think I saw an announcement about it. I don't know how many people here are familiar with it, but it seems like another one that we should be watching out for. Like, is there a quick summary of the difference between workflows and loops, or is it kind of like the same thing?
Yeah, it's fairly different. So the way I would think about it is, there's these traditional scaling laws in AI. And, there's this like scaling laws paper a while back that kind of introduced this idea that the way that transformers scale and the way that LLMs scale is it's a function of the data, the size of the neural network, and the amount of compute that you use to train the neural network. And so this is this kind of exponential property of the model. This is why intelligence keeps increasing exponentially, is because of these three scaling factors. Over the last couple of years, what's happened is we've actually added a fourth factor, which is test time compute. And essentially what this is, with test time compute, it's actually just a fancy way of saying how many tokens does the model generate. That's it. So there's a way to make it so the model can productively generate more tokens in order to achieve a better outcome. There's a few ways to do this. One is effort settings. And so, for Claude models, there's like low effort, medium, high, extra high, max. This is a way to configure how many tokens essentially you want the model to output. This is tuning the test time compute behavior. The more tokens, the better the result. The second way to do it, which we just introduced, is dynamic workflows. And this uses Claude to essentially write a little kind of like program that's running actually in a virtual machine to orchestrate other Claudes to solve a problem. It's a new form of test time compute that we're still just exploring, but essentially it's a way for Claude to, launch dozens, hundreds, thousands of agents to get work done.
Wild. Awesome. Okay, next question. What are some of the hard problems that Fable has had a hard time to solve?
Yeah, I think that, our models are not perfect, and there's a lot of, places where they still need to improve. One of the places is product sense. So I still come up with better product ideas than Fable does.
So idea generation.
Idea generation.
Yeah.
Yeah, it's not there yet.
See that. Okay.
Its code is now better than the code I would have written. Its front-end design is better than my design. Another place where I think I'm still a lot better than Fable is distributed system design. So kind of thinking through what are the services, how do we organize it, how does data flow, how do we think about load factors and things like that. This is a place where I think Fable is still, there's still opportunity to improve it.
How many more months before that's not true anymore? Or weeks? Or days?
I don't like giving predictions, but I would say probably by the end of the year, it'll be quite good.
Okay. All right. We heard it here. We're approaching the last few minutes, so I'm going to probably close this out with this last question here. This is a question from Andrew. He asks, how do you prevent engineers from getting lazy and accepting everything they output in Claude?
There's a couple ways to think about it. One, I think there's maybe two parts to this question. I think one part is, how do you make sure that the output is really good and that people are kind of doing the right thing? One way we think about this is, how do we get Claude to do the right thing so you don't have to? And an example of this is, since the beginning, we've had these permission prompts for Claude code. And, the prompt, anytime Claude wants to run a command on your computer, it asks you, is it okay to run this, yes or no? Can I run this bash command? Can I use this MCP? Can I fetch this URL in a browser, yes or no? And an engineer sitting there has to approve it or decline it and say yes or no. And something that we found is, over time, it felt like you get kind of a little lazy. And, at least for me, I just kept saying yes. I wasn't really reading the commands. And I'm sure this is kind of true for a lot of people. I don't know if you admit this to your boss, but... And so our security people actually saw this, and they were like, hey, there's a human in the loop. The goal of that human in the loop was to improve security. But actually what's happening is that it is hurting security because people are just they have this prompt fatigue. They just keep saying yes without actually reading the details. And so the thing that this led us to build is auto mode, which is a new permission mode in Claude Code. This is what we use internally at Anthropic, and actually now the vast majority of our users use it also. And what this is every permission prompt we route to a model, and the model decides yes or no based on what you've said so far in that conversation. And not only is it more secure, and we've kind of shown that the results are better than dangerous mode and better than the default yes-no permission mode because of prompt fatigue, but it's actually kind of one less thing I need to do as an engineer. And so the thing that it unblocks is very long-running agents. Because you don't have to sit there saying yes or no, it means I can now run Claude for hours or for days. And there's all sorts of benchmarks that show that, Claude is the best at these kind of long-running tasks. And of course, there's years of research that went into making auto mode working because that made it work. Because if you look at, Claude models, they're essentially not resistant to prompt injection anymore. They're not susceptible to prompt injection anymore. And this is a thing that I think surprises people sometimes. But if you look at our system cards, the success rate at 100 attempts is around 1%. It's just by far the best in the industry. And when you take this and combine it with a prompt injection classifier, which we run for a large share of traffic now, essentially the models are not susceptible to this kind of attack anymore. And what this enables us to do is ship auto mode. And what this means is that as an engineer, I don't have to sit there and say yes or no. So this is, I think, part one answer to the question, which is let Claude do more and figure out how do you unblock Claude to do more safely rather than trying to control yourself. I think the second thing is kind of what is the feeling day to day as an engineer when you're not writing the code anymore? How do you still learn? How do you still stay in the loop? And actually, one thing that I found really powerful for this is output styles in Claude Code. Whenever any new engineer joins our team, we tell them to use the exploratory output style. So this is just like /config output style equals exploratory. You run this in Claude Code, or you can ask Claude to set this for you. And what it does is that anytime Claude will make a change, it'll explain to you, hey, here's how the architecture works. Here's how this language works if you haven't used it before. Here's how this part of the code base works. It'll explain to you so that you can learn. And then there's also a learning output style which you can use, and this is for people that are not coders. And it'll explain to them, hey, here's like how this language works. Here's like, you know, like at a very basic level, it's going to teach you how to do the thing instead of doing the thing. So it'll say, okay, in JavaScript, you know, for example, here's how something works. I'm not going to make the change for you. I'm going to walk you through it. Step 1 is open this file and edit it in this way. Step 2 is run this command. Okay, I see you've done that. Step 3 is do this. So actually, I think like output styles and using Claude even more are a super powerful learning tool. And it helps me as an engineer kind of understand what's going on even as our stack.
Awesome. Well, we're at time. It's been, like I said, it's a very interesting time in our industry, and it's been a privilege to have Boris here working on Claude Code share some of his thoughts. And yeah, let's give a round of applause to them. Thank you so much.
Yeah.